All right, welcome everyone to the 2025 edition of Flutter Friends. We couldn't be happier to invite you here to Stockholm, and also I want to give a shout out to the viewers online, because the entire event will be streamed online, both the main stage and the studio stage, and you can watch the full stream recording afterwards, so you know. So I'm Alec, this is Lucas, Johannes, Daria, and Elias, and we're bringing this event for you today and tomorrow and yesterday. So I really hope that you had a lot of fun yesterday. Did you? Nice. So this event is all about community. So the social events and the dinners and the parties are really important, because this is what lets you guys to form new friendships and professional connections. And I hope that you recognize some people when you came into the venue today and not felt like you were alone. So some practicalities. First of all, smoking in the bathroom is absolutely forbidden. So for anyone who was not here last year, we had a fire alarm, and it was not good. So please refrain from smoking indoors. If you need to smoke, go outside. Thank you. So bathrooms, you can find them when you go out and to the left. We have some emergency exits. We have emergency exits here and over there as well. There's a wardrobe downstairs at the main entrance of Kulturhuset, so you need to go out and down the escalators, but there's wardrobes there if you need to. Also the studio stage, the second stage, you find that by going down the spiral staircase. And unfortunately, it's a long one. So if you think, like, are you there yet? Well, you just keep walking a little bit more, and you're going to see it. So yes, we're going to have lunch at 11:40, and it's going to be one meal per person. You're going to have it packed. So anybody who filled out allergies and their attendee preferences, you can find those separately. So please ask the catering staff for that. And if you experience any kind of issues or safety issues, please contact any of us in the staff. Okay, thank you. So I'll hand it over to Elias.
Okay, perfect. I just want to give a shout out to our sponsors for this year. Our platinum sponsor, AppShack, and our gold sponsors, Flutter, ServerPod, Firebase. Silver sponsors, Scandia, Lean Code, Invertus, that is giving out the prize for Flutter in the Dark, Fair, and the event is also done together with Bluefire and Dun, our streaming partner, CodeMate, and our party sponsors, PostHog, that sponsored the pub quiz yesterday, and they're going to give out some merch for the winners today. And Widget Book, which is sponsoring the party tonight. Give it a round of applause to all our sponsors. Okay, thank you.
So let's go over the schedule.
Yes. Oh, perfect. They're just magically working behind the scenes there so they know when I should talk. Yeah, so I'm going to be your host on the main stage here. And directly after we're done talking here, we will have Filip first with the boring keynote. You might have seen him on YouTube before. And after that, we will start having both talks up here and in the studio stage in parallel. So we're going to go ahead with Slava afterwards. And you can find I'm not going to read the whole schedule for you. You can find the schedule in the app and on the website if you don't have the app. And also, in the app, you can put whatever you want on the badge. If you go to the little icon in the corner of the app, you have a little badge menu there, and you just like tap it on, and you can have whatever you want on there. And if you saw the little cards that you got at the entrance too, that's NFC cards that are empty, so you can put whatever you want on there, like your LinkedIn or something, and it's really handy to just share with the people that you meet. And we're gonna try to be out of here at around 6 or so. That's pretty much it.
I don't know what to add to this, but I mean, we have the studio stage with some pretty good talks as well. So I would recommend you all to go down the spiral staircase and visit us for any of or all of these great talks.
Okay, what? Yeah. The official events end at 6 o'clock, but the fun events start at 7 o'clock. And the famous after party of Flutter Friends is a short subway ride from here. We will post the exact location in Slack and on the social media, but if you've been here previous years, it's the same location, so third time is tradition. And it will be a fun event. The doors open at 7 o'clock, and don't feel pressured to be there exactly at 7, because at 9 o'clock we have the competition called Flutter in the Dark. And if you have not participated before, this is where you basically create a UI, a task of UI in 10 minutes without compiling, and then we compile it all at the same time and see who's the best. It's very fun to watch and participate, I guess. And this year, we will have also same computers. So if you have trauma from previous years, this year it will be better, we hope. But yeah. And that's not all. If you think that we are crazy, well, this will be confirmed in a second, because also we will have real tattoo master during the party, and you can get Dash, Flame, Capybara, Flutter Friends, and also some not Flutter related tattoos. But if you get Flutter Friends tattoo anywhere on yourself or on somebody else, I don't know, you get a free pass forever to Flutter Friends. So, yeah, there's that. Did I?
Hey, give it up for that.
And the location of the after party can be found in the app and on the schedule on the website too. You have maps links there.
Also tomorrow there's going to be workshops and hackathons, both for the badge and a game hackathon. So we're going to cover that later today as we finish off. So now it's just time to have fun, enjoy, and listen to some great presentations. So thank you very much.
How many of you in here recognize Filip? Hand up. Pretty much everyone. All right. Stage is yours, Filip.
Thank you. All right. Well, first of all, thanks all for coming and also for inviting me. I really think Flutter Friends is possibly the coolest Flutter conference of them all. And I'm not kidding. I'm like, this is my first time, but I've seen so many really cool talks from here. So I'm really humbled, right? Now, it has come to my attention that keynotes aren't supposed to be boring. Keynotes apparently are supposed to be exciting about like new things and cool demos and all that, like very interesting visions. And I'm not doing any of that. And the reason is that I recently asked myself a question that I hope that you will ask yourself too. It's a very simple question. Why do I like Flutter? Is it because of the cool new stuff, or is it maybe about something else? And the thing is, like, I do like Flutter. For the past 4 years, I left Google, went back to Europe. I had all the opportunities to switch to other different frameworks, and I tried for both apps and games. But I always come back to Flutter, and I think I still like Flutter the best. Why is that, right? Another question, why does Dart spark joy? Because it does, right? And again, I am a neophiliac is what they call it, when you like new stuff more and then you want to try new stuff. So again, I did all the things like C++, C#, TypeScript, Kotlin, whatever Godot uses as a programming language, GDScript, and it's really great, right? But then again, if I'm being honest, I like and enjoy Dart more. And you could say, oh, it's because it's familiar, because you've been using it for I don't know how many years. But I think there's a deeper thing here, and I think it's that it's actually the boring parts that are important and that make the things enjoyable, right? So I want to make the point in this presentation that the Keynote level features and all the like Hacker News worthy stuff is of course nice and important, but why we really care about the things that we use is the more mundane and ordinary. All right, so I want to start by giving an example from another field slightly, and that is game development, because that's what I'm doing 50% of my time. And also, I think it's more kind of visceral. There is a field in game development called game AI, right? And it's literally just what do the computer-controlled characters in the game do? So in something like Pac-Man, it's what do the ghosts do? Like, what's the behavior, right? And it can be, and it generally is, like kind of boring algorithms. Like with Pac-Man, it's just if-else statements. These days, it's behavior selection. It's pretty boring, mundane stuff, right? Or it can go to really amazing, cool things. I'm really fond of something called goal-oriented action planning, GOAP, which is like where every character in the game that's not player controlled can actually make their own plans that are original and that can actually like surprise you as a developer that, you know, okay, this soldier actually came up with this cool plan how to do X or Y, right? And so you can imagine, okay, so there's these two approaches. One of them is the boring one, if-else statements and so on and so forth. And then there's the glamorous one, the one where you talk at conferences about it and it's really, really cool, right? And we all know which one we would like to discuss more at a conference. But if you ask people that are in the industry, like game AI experts, not me, but like people who've been doing this for 10, 20 years, they'll tell you this. The job isn't making the game AI brilliant, it's making it not dumb, right? So it's like, it's not about like the cool GOAP things. It's the boring stuff that actually makes the game AI good and therefore the game good. I'll give you a live demo. So imagine that, so that you know what I'm talking about. Imagine that I'm a soldier in a game, right? Or any other character in a game. And I'm here, there's like a button over here, and there's a door over here that's closed. And if you press the button, it like toggles the state of the door, right? So simple stuff. And let's say I'm the soldier and there's ammo over here and I want it. So if I'm going with the boring AI, I'll do something like behavior selection, which is basically just like I'm going through the different behaviors that I can do. One of them is pick up the ammo. I check, can I get to the ammo? The Pathfinder says no. I'm like, okay, I'm not doing that. And I'll just play an idle animation, like I start whistling or whatever. If the player sees this, they're not impressed, but they're also, like, I don't look dumb. It's just, okay, he's just standing there, right? Now, I am the AI, the glamorous one with the action planning, right? So this is the glamorous me. So I'm the soldier, right? Now, I figure that I need to do something, so I start action planning. And one of the plans is, okay, you go here, you press the button, you go there, you take the ammo, right? So that's a good plan. I start executing it. I just go and get the ammo. And this could be pretty, I don't think it's brilliant for the player, but if the player sees it, they're definitely, they'll like it, especially if they were the ones who closed the door. Or maybe it's just like, okay, this is a scripted event, blah, 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 right? If it's a game developer who sees this, they're definitely impressed because they're like, oh shit, this is action planning. So, but anyway, right? So far so good. But imagine there are two soldiers apart from me. So now again, back to boring. I have behavior selection. Look, I can get there. I just play an idle animation. The other guy does the same thing, idle animation. The player sees this, fine, okay. Two guys standing around, right? Now, what happens if for action planners, right? So I make the plan, so I start executing the plan. The other guy also makes the same plan, and so while I go, I open the door, and I start going to the door. The other guy comes to the switch, closes the door, and starts going towards the wall. Now, the first one is like, oh my god, my plan failed. So it goes, oh, I know what to do. I'll, tap the button. And so on and so forth, and it looks dumb. If the player sees it, it looks dumb, even though you have this amazing, elegant solution at first, right? Now, you might be thinking, is it not possible to fix this? Like if you have Go app, goal-oriented action planning, is it not possible to make it not look dumb? Yes, it is, but the solution will be boring. It's not going to be as elegant. That's what I'm trying to say, So it's not all about the cool stuff, and the more important for the player or the user are often the more boring stuff. Right. So like back to general computing, the vast majority of development time is spent on the glamorous stuff, despite us talking a lot about the glamorous. All right, very quick agenda. I'll just basically talk about a bunch of seemingly random stuff at first, about 11 examples. I don't have them sorted in any way, but at the end, I'll try to generalize it at the end, okay? I just wanted to make sure that you're not missing anything. If it looks like I'm jumping from one topic to another, it's just random stuff. Also, I want to say, what I'm going to talk about, most of this is not unique to Flutter and Dart. It's not like, Dart is the only programming language that has fast GC. It does not make, like, if you have a programming language that has fast GC, it does not make it automatically enjoyable to use. I'm talking about the compound effect of all of that. All right, so number 1 out of 11 is that Flutter has a single pass layout algorithm, meaning that if the layout, it's like just, you probably know this, right? Constraints go down. Okay. Yeah. I was very kind of, I thought we would be like screaming at the top of our lungs, but all right, okay. It's the morning. So anyway, so that's like, that's just how Flutter works. And what it means is that layout is ON, so it's linear time, which means it's pretty fast, right? And that itself is really boring. You can't really show it on a demo. It's not visual. It's just math that works. It's not really that interesting, but it unlocks a lot of things. My favorite one is that if you have scrolling in your app, it really is nothing else than layout, right? There's nothing special about a scrollable widget. It's just relayouting every frame, which means for you as a developer, you don't need to think about, oh my God, this widget is part of a moving scrolling thing, so it can change sizes or whatever, right? Like, or I need to use like some adapter because something. No, it's just relayouting every frame. That's it. Another one is that Flutter has an integrated rendering engine, which is just like, I always say it's like, Unity for apps. There you actually have like a little rendering engine in every app that you publish, which is again very boring, especially for people who've been doing this for a long time, but it's amazing, and I'm very surprised that nobody has tried to emulate this. It seems, as far as I know. Well, I know why, because it's hard, but it's kind of like a unique thing for Flutter, and this also has a very real effect for us as developers, and that is that we are not like, hey, operating system, can you like maybe show these buttons there, and fingers crossed it looks kind of like I wanted to see. No, it's like it's literally you and the rendering engine together, like doing draw calls, and you can go all the way to individual draw calls and do exactly what you want, and it will look the same. You know the drill. It will look the same on Xiaomi and Samsung and iOS and all that. So that's a huge part of it. It's a lot of work on the Flutter engine side, but it gives us a lot. Another my favorite thing maybe is that animation is just rebuilt. So if you go deep enough into any animation, including like fade in transition and so on, it really is just like reset state on a widget at some point, right? So there's nothing special about these rebuilds, which makes it very flexible. Like you can, if you wanted to, let's say you have an animation that slides something from left to right, you want to show Rick Astley every third frame, you can. It doesn't like, the Flutter framework doesn't care, it just like will do whatever you want them to do, right? Now, it seems like it might not matter because of course, you want all animations to be continuous. Of course, there's really only a few animations that you want, like, fade in and fade out and scale and translate and rotate, and that's it, right? But that's actually not the case, and I want to show what I mean. Let's talk about probably the most boring transition or animation of all, and that is fade in, right? So this is how you fade in. This is using Apple Keynote, which I'm using for this keynote. And that's just, you're going from fully transparent to fully opaque. And it's good enough, right? It's good enough for Apple, so it's good enough for us, right? Wrong. If you look at how they do it, how the film industry does fade in transitions of like things like titles, you'll see that they are doing something like a small thing that I haven't seen much in UI in like computers, and well, I want to show you now. So this is the title sequence for a movie called Snatch, but you'll see it from now on. You'll see it everywhere, and I don't know if you could see it on the screen, but basically they don't go from like fully transparent white to opaque white. They go through this like kind of a blue effect, which is really like it happens very fast. You don't consciously see it, but it makes the effect very. Not very. It makes it interesting. It's visually interesting. It adds visual interest, right? So how do you do it in Flutter? You don't use fade transition. You just have a color. If you're only fading one color, you have a color tween from transparent blue, for example, to white. By the way, I've ruined movie going experience for you, because from now on you will always look at titles and you will be like, oh yeah, there's the blue there. Okay, so but yeah, it really is there, and most people have never consciously seen it, right? So that's what I use in my game. You probably can see it here, but trust me, it looks cool in the normal, here it looks cool. But it's subtle, yeah. That might be fine with other frameworks, I'm sure. I mean, it's all possible in other frameworks as well, I'm sure. But what if you want to animate in something that has more than one color, right? So it can be just one color tween. Animations are just rebuilt. So you have an animated builder, you have color filtered in it, and you just animate that, right? You modulate through blend mode.modulate, and this is how it looks like. This is probably me overdoing it. And I'm not sure if you can see actually that something's happening, but like it goes, all of these things go through a slight blue kind of tint, right? And I think that that makes a big difference actually in the end. So animations are rebuilt. Number 4, gesture arena. So, is everyone familiar with what gesture arena is? Yeah, not everyone. Okay, so I just want to highlight how cool it is that Flutter internally has this thing to deal with different kinds of gestures. So if you need in some part of your UI, if you need to double tap, then Flutter will automatically wait until it's sure that you're not double tapping, right? So I have an app and I tab here and that button has both a normal tap and a double tap. And so like it taps, I mean, it registers the user input, but the framework is like, oh, but maybe this is a double tap, so I will wait until later. And then when it's sure that it's just one tap, after a while it will tell you, okay, it will call your callback on tap or on pressed or whatever. But if you have another part of your screen and maybe you are only interested in on tab down, so like not even taking away your finger, but just like touching it, gesture arena is smart enough to be like, oh, there's only one gesture that the developer is interested in, I will immediately fire it, right? Which means that you have a lot faster feedback, and it's just like your app or game, it's especially interesting for games, can react immediately like the next frame, which again can be a subtle difference, but it actually makes a difference. It does. All right, so Flutter has null safety. A lot of other programming, Flutter, Dart has null safety. A lot of other programming languages have a null safety, but not always is the null safety sound. And again, you all know this. That's why it's called boring Keynote. But just imagine that you had a method or function, and the argument of the function would be non-null, but there could be a possibility that what you get, the object, is actually null. That's what unsound null safety is, basically, right? This is very rare, but it's still, you know, like you're basically crossing your fingers that it doesn't happen to you, and that's bad. So implementing soundness soundness is hard, and it was really, I remember the time of like the switch and so on and so forth. There's a bunch of complexity. It's boring. You don't want to speak about it on most keynotes, but it makes your life much easier and therefore your programming experience more enjoyable, I think. There's a standard library, which is also not unique to Dart, but it's well designed, right? Like you can have standard libraries that are that basically don't give you a lot of things that you want, like, you know, trim. Or you can have standard libraries that like pollute your namespace with like crazy amounts of different things. And it's kind of boring, but important to have people that are the ones that you know, make the hard decisions to say this goes into the standard library and this doesn't. And it's not exciting. You're not going to go to Hacker News and post like, I like this standard library, and everyone like, yeah, that's great. No, it's not something that we think about, but it's really important. Number 7 out of 11, integrated toolchain. So the fact that we get Flutter format, Flutter analyze, Flutter pop, Flutter doc generation, dev tools, Flutter inspector, you know, built-in text, and a bunch of other stuff. I did a very like low effort thing, like this is AI generated, so please take it with a grain of salt. But I basically asked AI, give me this, like try to see what's built in. So the green ones are built in. The kind of light green ones are not built in, but kind of standard. And then if it's the dash, there's no real solution, or it's highly fragmented. And I didn't tell it like make Dart look good here. I didn't even tell it this is about Dart, but it did this. And this is not me saying like this is the reason why you should think that Dart's toolchain is the best. No, I hope that if you have experience with other tools and programming languages, you see it even without the table. But I just wanted to show you something. So that's I think is important because again you don't need to think about this too hard. There's a toolchain, and it's standard and it's built in. And for that I give the example of like an encyclopedia versus a library. If you want to learn about Stockholm, you can either go the curated way, which is open encyclopedia, and you have a short article that is very opinionated. Someone put it together, but you're very quickly you're done, and you get your information. Maybe not the best information, but something, right? Or you can go the DIY route where you go to the library and you spend a week researching Stockholm, and then of course you have a better idea of what Stockholm is, but it takes a week. And so obviously if we all had an unlimited amount of time, we would just go to library for everything and like do DIY for everything. But in the real world, there are some things that you care more about than others. And so every tech stack needs to figure out what are the things that should be curated and like done for you, and what are the things that we kind of let you do on your own, right? And I think Dart and Flutter and many other frameworks out there are opinionated about infrastructure, but you are flexible about the app patterns. So for example, it's like Dart and Flutter are opinionated about the formatting and about the compiler, package management, stuff like right to left support. That's what you get by default. And you don't really have much choice there, or none, right? But most of us don't really care, I think, about like the exact implementation of package management. But on the other hand, we're flexible about state management and architecture and packages, right? And so again, this is a balance, so it's boring. There's no like really elegant solution to everything. You can't have everything curated. You can't have everything DIY, but that's what we get. All right, hot reload. Obviously, at some point, hot reload was a hot feature. It was the thing that we showed at keynotes and stuff like this. But what I want to highlight is consistent. So maybe you have experience from other tools with hot reloading and other kind of things like that. And you know that sometimes they're not stateful, sometimes they're not fast. And oftentimes, in my experience, they're not consistent. And that sucks. So you can, on the other hand, with Flutter, at least in my experience, of course, it's not 100%. But like I regularly start an app, and then for a week I don't rebuild it, and I just hot restart, hot reload, and it just consistently works, which is a huge amount of work on the side of the team that I don't need to worry about. Unified composition model, this will be maybe a little bit controversial, what I'm gonna say, but it's everything is a widget, right? So like padding is a widget, instead of being like a dot padding or something like this, right? I think that's actually a really strong point of Flutter so far. I know that there are ways and people are trying to change this so that it's less typing, so you can have like some widget and then you say dot padding and add padding that way instead of nesting it into a padding widget. I personally think that I'm not decided, but I think it's also good to realize how the simplicity of just like everything is a widget, everything is just nesting, is powerful, but it's boring. Like if you told it to someone, they're like, yeah, but yeah, I want to, this new thing. We'll see. Number 10 out of 11, something that is told about at every keynote, but only at the end, and kind of like, like thanks to the community for being here. But I think it's really, really important, the kind of community that's around Dart and Flutter. And I think a lot of engineers will be like, it's actually, all about the tech, the community, it's great, but yeah. But try to be in a community where newcomers are being seen as inferior, or people being dicks to each other, and that being okay. That gets old pretty fast, and it is part of your development experience, I think, with the technology, right? Whether you want it or not, if you're building in a technology, you'll probably partaking in the community a little bit, and if everyone is a dick, then it has effect on your productivity and your life. So that's a big thing, but it's also not only about toxic versus non-toxic, it's also about like the excitement. Like I know about tech communities, lots of them actually, where like the people are not really excited about anything, and they're like in it for the money, which is totally fine, of course. But if you're like in that kind of community, it's a very different experience. I just want, I don't know, maybe it's just me, but I want like people to feel alive if I'm communicating with them. So I'm really glad that the community is what it is for Flutter, and it's also part of the enjoyment, I think, for that. And last but not least, documentation is a huge amount of work, and it's, I think, for Dart and Flutter is amazing. The API docs, but also the Flutter website. I know firsthand that it's a lot of work. It's all peer-reviewed, and it's being maintained, and it's boring to talk about. All right, so I talked about all this. Of course, in isolation, all these things, and I could be talking more, right? I had like 10 more examples, but I don't want to bore you too much. But it's not about the isolated things, it's about the compound effect. You have this thing where all these little things together make your life or developer experience more enjoyable. I also want to say that all these little things can only exist if you don't have too many complex features. So if you have something that has like 100 features, then of course you can't get that much attention to detail to all of them. You have to probably kind of skip some of those, and maybe they're there, but they're not really thought out, and so on and so forth, right? So it's really important that we realize that the Dart and Flutter teams need to say no a lot to new features. And there are languages and frameworks that say yes a lot more often, and I think they are, at first, they are very popular because, of course, it's like, oh my god, they added my favorite feature now. So you're like, yeah, but then after a while, it's a nightmare because there's like all the features, and now it's a complex mess, right? Also, I want us to, I think in this room, mostly we're experts, or like we've been working with Flutter and Dart for a while. So for us, we have ingested all of the complexity of Dart and Flutter already. So if there comes a new feature, we're like, of course, it's just like this thing. I can understand it and ingest it into my already existing knowledge in a minute, and I'm excited about it. That's great. But if you do this too long, then you get this like huge complex mess. And suddenly, for newcomers, it's going to be very bad. Like, I don't know if you've ever tried to, like, get into C++. It's like, I can understand how they got there, but when you're starting to even just read C++ code, you're like, what is happening? So you don't want that for Dart, but it's easy for us to just kind of like, sleepwalk into that because, of course, yeah, that's great, that's great, that's great, and suddenly you have this complex mess. So yeah, let's not do that. So I want to leave you with I guess an obvious thing to say is that reliable foundations enable creative applications, which means the kind of the boring stuff that's down there and that we don't talk about is actually what makes cool apps and cool games and everything like that, right? So my example is the Sistine Chapel is made from regular timber and stone. Banksy uses regular spray paint. Minecraft was built in Java. And it's the most successful computer game of all time. So obviously this is like, I think we can all agree. And we kind of need the Flutter team to be the reliable ones. Just to be clear, this is not me saying that like I'm against improvement or like I hate new features. I've been talking about this for 30 minutes, so I get if you think that, but no, I want Dart to be improved. I want new cool features. Obviously, Dart and Flutter can't stay still. If it's just stand still, then there will be no new blood and so on and so forth. So it needs excitement. But let's just always remember that the job of the Dart and Flutter teams isn't just the shiny new things, it's making it not dumb, meaning making it a little less frustrating, a little less, maybe a little more performant, a little more enjoyable to use. Thank you.
Mic'd up. Oh yeah, super good, super good. I loved it. Let not leave me hanging. All right, so now we will soon have Slava on the stage up here if you want to go into more nitty-gritty technical details of Dart. I don't know what he will talk about, but I'm guessing that it will be something like that. And if you're more into accessibility, we will have that with Enzo in the studio stage downstairs. Which will also be a great talk, especially now with the WCAG being basically mandatory in Europe. You don't have a badge? No, I'll do that after your talk. I think people have started to getting a seat. Slava has been here 3 years, all years we've had this conference, and it's not to pick like favorites, but Slava's talk is always my favorite every conference. So for the ones of you that don't know Slava, he works in Denmark with the Dart team. And do you have the same title as you had last year? Uber TL or something?
Yes, I have the same title. The job description, I guess.
Yeah. Yeah, so give it up for Slava, and he will tell you everything about the isolates.
Yeah. Okay. I think this works, and the slides also work. Okay, perfect. Hello, everyone. I really did try my best to not come this year because it's very stressful to give talks, prepare slides, and so on and so forth. So I delayed answering emails and so on and so forth. But then I remembered how cozy it is here and came anyway. It's just 40 minutes of suffering, and then I'm free. Also because once you heard the person speak one time, okay, it's novel. Second time, you start seeing that there is actually patterns in what people say, how they make jokes, and so on and so forth. And then the third time, you're like, oh, this is boring. So I will try to not repeat my patterns. There will be no assembly code on the slides, and so on. Yes, for those of you who have never heard me speak or don't know who I am, never saw me on GitHub, I'm Slava. I am this person. I am overall technical lead for the Dart project. This means I get to decide how Dart evolves. Well, not really, actually. So that decision power is more like an emergency stop in a train. Mostly, I just channel creativity of my talented colleagues, of whom I have many. And try to influence them so that they go in the direction which I think is important for Dart and Flutter users. And one of the topics that occupies my mind, of many topics that occupy my mind, like what to have for breakfast, lunch, and dinner, and so on, it's a question of concurrency in Dart. Because this is something that people encounter from time to time when they write code, and that's what I want to talk about today. I want to talk about concurrency in Dart, because I think a lot of people misunderstand how concurrency in Dart or concurrency in Flutter work, and why they're the way they are, and where we're taking them from here. Okay, so if you're a seasoned software engineer with, I don't know, 30 years of experience behind your belt, you have used 10 different programming languages in your life, then maybe if I put a sentence like this on the slide, you'll be like, yeah, this is clearly makes for me a picture of what Dart is and how its concurrency is structured. But if you are a more junior engineer, you're just starting, you'll be like, what is this even? And if Dart is your first programming language, and there are such people, you will not know what even a thread is, right? Or what run to completion means. So I will start by giving a little bit of a gentle and very brief and mostly incorrect introduction to concurrency in general, how our hardware or operating systems work, so that you have at least some foundation to understand the rest of the talk. Okay? So we have these fantastic pieces of silicon in our computers or phones that called CPUs. I'm not going to go into how they work, because then we will be like quantum mechanics and electrons and whatnot. So let's not go there. Let's just pretend there is this thing there, and it executes instruction by instruction, and these instructions, they all do something, do some operations, mathematics, they read and write memory, right? And it would be pretty tough to program these things if you wanted to do many different things, but you had to manage this manually. Like right now, I want to put pixels on the screen, and I paint a little bit on the screen. And right now, I need to read this file from the disk, or I need to send this request to the network. And you have to manually manage and switch back and forth between these tasks yourself. People have tried it many years ago, right? Windows 3.11, right? For work groups, if you remember that thing, or macOS 9. Or before, they had this cooperative multi-threading where if you run something on your CPU and you forget to yield CPU to other programs, well, the whole thing freezes, right? So people quickly figured out that for the kind of consumer applications, it's pretty tough to program like that with cooperative multitasking. So instead, they came up with this concept of preemptive multitasking, threading, whatnot. You have these threads, which you can create many of, and they all work on the same memory, but they do different things. They're kind of like tasks. And then you ask operating system to handle switching between threads for you transparently, right? So it can allocate the CPU for a little bit to one thread, and then it can give it to another thread, and then to a third thread, and then switch back to the thread number 2, and so on. So this all happens transparently. And that's basically concurrency 101 in modern native programming, right? Of course, real picture is more complicated than this. CPUs have cores. They're not like just one CPU. Even in the phones, they have like, I don't know, 4 or 8 cores. We don't have symmetrical cores where all the cores are the same. You have cores that are more fast but consume more power, and you have slow cores which consume less power. Some phones have even like 3 types of cores. Some are super efficient cores, and some are super fast cores, and so on. I'm not going to go into all these details. It's just important to understand that there are threads, and the operating system manages allocation of computing resources to the threads. Okay. And another important thing here is that all these threads, they work with the same memory. And that's what shared memory means, right? The memory shared between threads, they all manipulate on the same memory. Okay, within a process. Process boundaries separate different memories from each other. Okay, so now let's jump into the Dart world. In Dart, there's no threads. If you search in the Dart documentation, the word thread maybe occurs somewhere in the corner of isolate documentation. So if you're starting your programming life from Dart, you are like, what is even a thread, right? You don't know what thread is, but somehow Dart code still executes without threads. So how does that happen? Well, if you read, again, getting started, I don't know, language tour, eventually you figure out that all Dart code runs in something called an isolate. And we don't know what it is, and the whole purpose of the talk is explain what it is. So I will just draw a box here and say it's an isolate. And that isolate has some space where Dart creates objects. So when you, for example, create a node duration here, that's where it's going to reside, in a heap there. And it also has a space for static state of your program. So for example, here there is a counter, which is a global variable, and it's initialized to 0. It's initialized to 0, but here it says 1. That's a typo. Does not matter. It should be 0. And if you change that, it's going to change in that space. So, and in reality, that's all what isolate is, end of talk, right? It's a space for storing things. It's a box where things reside. And when you run this program, it's going to update that space where things reside, and so on and so forth. Okay, perfect. Cool thing about isolates, and it should say isolate B. Don't edit slides in the last moment before the talk by copy and pasting stuff. Copy and pasting is bad anyway. So it should you can create another isolate, and it would have a completely separate space for allocating things, and it would have a completely separate space for storing the static state of your program. And you can run them concurrently, and they will be completely independent from each other. Okay. So, but notice I used to draw threads as kind of lines with arrows. They're kind of active things. And isolates I draw as boxes. And that's because, like, many people think isolates are like threads. There is this misconception. No, isolates are not like threads. They are space where things are stored. And they don't actually perform anything actively themselves. They just exist. Like humans just exist. To actually execute stuff, you need actual operating system threads, native threads, and you need to use them to execute your Dart code, right? And the way it happens is that you have an isolate and you have a thread, and then you say, well, now this thread is working with this specific isolate. And we commonly, at least on the Dart team, we say that a thread enters an isolate. And when it entered the isolate, it can execute code within the confines of that isolate. For example, it can call that function foo that I showed on the previous slide, which works with that counter. When it's done, it can exit the isolate, and it's no longer using it. And while this is happening, another isolate, and here it is correctly called B, because here I did not edit it in the last moment, in the other thread can do the same in a different isolate. And this is how threads and isolates work together to actually achieve execution of your Dart code. Okay, so far so good. So the isolate club has some rules. Of course, the first rule is that we never talk about the isolate club, right? The second rule is that each thread, each native thread, can only enter one isolate, at most one isolate. So you cannot have a situation where one thread simultaneously works with two isolates. That is not allowed. And there is a kind of conversely or inversely or whatever, for a specific isolate, only one thread can be there at the same time. So if two threads try to enter the same isolate, it's not going to work. So they are kind of mutually exclusive. And that's why, for example, on that slide I showed, Dart is a single, like people often say, Dart is a single-threaded language, even though you can spawn the isolates and so on and so forth, because within each isolate, you are confined to a single thread of execution at the same time. And final rule is that isolates can't interact with each other directly. Okay, so far so good again. So how do the isolates interact? Well, each isolate has sort of a message box, and the outside world can put messages into this message box, and these messages are destined to be delivered to some specific ports. If you work with isolates in Dart, you know they have the send ports or receive ports. These ports can have listeners. So the external world, it can be other isolates, so it can be native code. It is sending messages to these ports through the message box, and then the message box is going to deliver them to specific ports. Again, this is all boxes, so there is no actual active. Nothing is active here. Isolate by itself is not going to do anything. You need to have a native execution thread. You need to, for that thread to enter the isolate and say, well, please drain your message box. And then eventually the message box is drained, all the messages are delivered, all the callbacks are called, then thread can be done and go do something else. Okay. So that's all there is to the isolates and the kind of isolate programming model in Dart. You have these isolates, they're completely separate from each other, they exchange messages between themselves and with the native world. Everything is a message, like if you want to read a file asynchronously, you ask some native thread to do it, and then the native thread is going to send you back the file content in a message. It's a very nice model, but if you come from a more classical programming languages like C++ or Java or 100 other programming languages, you're like, what the hell is that? Anyway, so if you go back in time and watch some talks from early days of Dart, Lars Bak, who was the original founder of the Dart project, he gave a talk in 2012 on a conference called Strange Loop in St. Louis in US. And he said, well, we created this programming language called Dart, and we took the design from Erlang for isolates. And whenever I hear this quote, and this quote is quite often appears in the marketing documentation, I'm like, really? Because if you actually know Erlang, and we're in Sweden, so you're supposed to know Erlang, right? It's a programming language that was created here in Sweden. It was created at Ericsson originally, then open sourced. It's used for programming at least it used to be used to program telecommunication equipment. It's created for highly concurrent distributed systems. It's a fantastic language. It looks nothing like Dart. And it's like its process-oriented architecture is much more clean and neat than Dart's. So the Dart, like it's saying that Dart is inspired by Erlang is like saying that this is inspired by Mona Lisa. I mean, you can see the shape, but it's not exactly the same thing. So I joined Dart project at the point when the design for the isolates and for most of the, like what was Dart 0 and Dart 1 was already done. So I didn't participate in those discussions. So I was like, how did this actually end up being this way? I didn't know. I had educated guesses based on my experience how it went, but I decided to go to the source. I did not want to bother Lars, who retired, but I sent a mail to Kaspar Lund, who was his second in command when designing programming language. I sent him a mail, he sent me a response, and the answer is, of course, JavaScript, just as I have guessed myself. JavaScript has very limited ways to do multi-threading, and even that appeared only like 2009 web worker specification. If you look, when was the first web worker specification published? It was published 2009. And you know who published it? Jan Hickson. He was the author of the specification. He used to write specifications for the web features for the browser. So JavaScript has this same single-threaded, event loop-oriented, isolated execution story. It has web workers, and you can spawn these web workers, and they exchange messages. And it looks, the Dart system looks quite a bit like the JavaScript system, and much less like an Erlang system. And another part of that story that Kaspar told me is that Lars had very bad experience implementing multi-threading in JavaVM because he worked on a hotspot before he went to work on V8 at Google, and then later started Dart project. And he had a much better experience with single-threaded virtual machines. But when you look back in time, both the hardware and operating systems, they advanced a lot since then. Like synchronization between threads used to be extremely expensive back when Lars was developing the first versions of Hotspot. And it's no longer the case. There were advances in all of this. So some of this bad blood that he had back in the day maybe doesn't apply these days. But we ended up with what we ended up with, isolates. OK, great. OK. So what are the problems with isolate, if you ask me? Well, first of all, nobody understands them. Nobody gets them, right? How many people here get isolates? Yeah, look, like barely anybody, and yes. So even if you look at the Flutter, you realize that, like when I was describing this original message passing model and stuff like that, I'm pretty sure many of you get a light bulb moment when you're like, oh, this is like platform channels. Yeah, it's like platform channels, but platform channels for some reason are not based on ports. They're re-implementation of the same idea in a different way. So when Flutter people were developing the first versions of Flutter, they came up with platform channels. They did not think to reuse the already existing abstraction. They created a new one for some reason. And that's because nobody gets isolates. Even the Flutter team themselves don't get isolates. So, and there was a bunch of issues with the original design and the implementation of isolates, which carried through the years. So let's imagine for a moment we are Flutter programmers. Okay, I will imagine because I'm not a Flutter programmer. You are a Flutter programmer, so you don't have to imagine. Anyway, so you wake up and you need to fetch some JSON from the web, right? And the first thing before you even get coffee, you need to fetch some JSON. And you write this code, and you're like, oh, wait, my JSON is 100 billion megabytes. I don't know why it is, but server people are stupid, and they send this 1 million gigabytes to me. So it's going to stall my whole UI while this phone is heating up and decoding the JSON to display one button or something like this. Anyway, it doesn't matter. But that's what happens, right? People send these JSONs out of which you use maybe 0.01111% or something, or doesn't matter. So, so you write this code. It's going to stall your UI thread, and the UI stops rendering, and it's bad. How do you solve it? Well, we have isolates, OK? So we're going to take this JSON decode, and we're going to stuff it into the isolate, right? Let's ignore for a moment this convenient API. It did not exist back in the day. We can pretend that like compute was there, right? Flutter compute. So we take it and we stuff it into an isolate. And then we try to use it, and we discover there are issues. It does not work. And I will talk about why it does not really work the way the way you want it to work. But first, I also want to use this code as an opportunity to show that nobody understands isolates, even if you think that you understand isolates. So for example, you can look at these two pieces of code, and you ask yourself, what is the difference between these two versions of the same function? When I would use one or another? And you don't have to, I'm not going to give you an answer now. You just memorize this slide, and I'm going to quickly switch to the next slide. So you just have 5 seconds. So think about what's the difference, and then you, after the talk, if you think you know the answer, you can come and check with me. I wanted to bring some candy to give away if you give the right answer, but unfortunately I did not. So yeah, so there will be no prize, but just satisfaction if you guess correctly, or disappointment if you don't. Or advanced version for people who really think they understand isolates. So again, there are 2 versions of the function. In one case, we have the HTTP client in a class instance, and in the other is just a global static thing. Okay. Again, what's the difference? When you would use one or the other, what kind of pitfalls do you get with isolates? Okay, so memorize this and come check with me. Let's get back to the original form of the code. So why did it not work? Like if we travel back in time to 2017 or something, if people would try to use this to speed up their JSON decoding or to make it not junk their UI, they would discover that things work awful. And here is why they worked awful. So you have this UI isolate, which is responsible for rendering your UI. You have this temporary isolate that you create and where you parse your JSON to a map, and then you send this map back to the UI isolate. Well, these isolates are completely independent from each other. So as I said, they have their own garbage collector managed heap, each of them. They have their own copy of a program that you are running in each one of them. So that means they're gigantic, they are monstrous, and they take huge amount of time to spawn. You start the temporary isolate. First, it needs to load this program in memory, unpack the snapshot. Then it starts running your JSON decoding and HTTP request, JSON decoding after that. Then it gets this huge map. Then it needs to serialize it into a message to send it to another isolate. So you pay for that packing of the map into a message, which you just deserialize from JSON. Okay, great, right? So you just deserialize it, and then you serialize it again into some other format. You send it over, and then the receiver has to unpack it. So what you replaced is like you replaced the slow JSON decode with a slow message unpacking. You did not actually solve any stalling problems. It's like, boom, does not help anything, okay? Fantastic, thank you for isolates. We realized it. I mean, we knew it kind of, but we realized that people will start hitting it more and more, given that we recommend them to use isolates which do not work the way they should. And that, by the way, goes back to that Mona Lisa picture. If you go and read, so Joe Armstrong was one of the noticeable programmers behind Erlang. He had a PhD about Erlang. And it's a fantastic piece of writing. You should read it if you are interested in that sort of things. He's also a fantastic speaker. He unfortunately has died. But he has a lot of interesting talks about concurrency and stuff like that. And if you look at his description in 10 lines what Erlang is, one of the lines there is, it should be fast to spawn and destroy processes. So isolates are not like Erlang processes. They were not fast to spawn and destroy. And that was a mistake. So we tried to solve it. And the way we solved it is we said, well, what if we abandon separation of heaps between 2 isolates? If you have isolates which are running the same code, there is no reason for them to be isolated from each other. And we merged all of the heaps from all isolates together, forming something called isolate group. And it gave a lot of benefits. The isolates became very small and fast to start. Some objects can be now shared directly, because previously you could not share any objects directly. They're 2 unconnected, garbage-collected heaps. You cannot just give a pointer from one heap into another heap. It's going to just crash the whole thing. We can speed up sending. Like if you're sending, you can do a quick cloning of an object rather than serialize it, or serialize, deserialize it. We introduced new API which allows you to, if you spawn a temporary isolate, do some work, and then you have some data to pass back, and you're exiting the temporary isolate. Then you have a special API where you say, I'm done with this isolate, I'm not going to do anything from this point on, and I have this data to send to some other isolate. You no longer need to copy, because you know that the isolate that had access to this piece of data, it's not going to do anything. It's dead now. So there is no longer need to maintain isolation for that thing. You can just pass it to a receiver without copying. The drawbacks of merging the garbage collected heaps is that GCs are no longer independent, that GC in one isolate can affect the like things in another isolate. And there appeared now a number, there is now a limit on the number of concurrently running isolates within one isolate group. And that's a bit advanced stuff, so I will just skip over it. So which objects can be shared? Well, obviously compile time constants can be shared, or things that can be considered deeply immutable, like strings, or we have a special pragma where you can mark a class as deeply immutable. It will verify that it has only final fields to allowed types, and such objects you can send without copying to other isolates. Okay. And if you look at the picture before and after, it became much better. So now you can actually use things for JSON decoding, but it took many years. Like it took 2 years of refactoring of the Dart runtime to actually get there. So now when you do JSON decoding in the other isolate, you actually can do it without pausing the UI thread, because you just pass directly the result back. You no longer spend time serializing, deserializing map once it's parsed, and so on and so forth. And you no longer spend time spawning, because that became much, much faster, 1,000 times faster, maybe more. Okay. So now the question is, how do isolates actually run? Because I previously said, well, there are threads, and you need a thread, and then you run an isolate on that thread. Okay, fantastic. But where do the threads come from? Well, if you create your own isolates, which some of you do, then they run on the thread pool that is managed by the Dart runtime itself. It will allocate threads dynamically as needed. The UI isolate, or UI isolates, because there can be multiple of those if you create many Flutter engines, they are run where Flutter engine wants them to run. So a few years ago, the picture would be like this. Flutter would create a thread for UI isolate. It would be a special dedicated UI thread. It would run the UI isolate on it. If you create one more Flutter engine, it gets its own UI thread for running its own UI isolate. And all of it runs concurrently, and everybody is happy. Except that if you want to communicate with a platform, the platform has its own dedicated UI thread, a main thread of Android or iOS. And operating systems usually have APIs which are bound to this thread. You can only use these APIs on this thread, or you receive callbacks about key presses and stuff like that only on that thread. And that creates a problem, because isolates are running somewhere on the auxiliary threads, and platform thread is there. So what Flutter did to solve this kind of is it said, okay, platform channels are there, and the platform channels handle messages on the platform thread. So if you want to communicate with the native APIs, you send messages through platform channels, execute some native code, and the native code will send you back the message to the Flutter UI isolates. Okay, fantastic. But what if you want synchronously call this? Well, that's the problem. So this isolate design and how the isolates interact with threads created the problem that you cannot easily call synchronously into the native APIs, and you cannot synchronously receive callbacks from native APIs, because some APIs are bound to specific threads of which you don't know anything in the Dart world, and sometimes you can get callbacks from native APIs on arbitrary threads, so, which again you cannot, because you need to be called in some isolate. You cannot just be called. Okay, and that leads to a conclusion that isolates cannot continue to ignore existence of native multithreading if we want a good interoperability story with the native world. Okay. So in the last few years, we have been trying to cross this chasm, right? So what happened in the last year specifically, Flutter team has been working on moving the UI isolates to the platform UI thread. So that whenever you run in the UI isolate, you know that you are on the platform thread. You can synchronously call into platform APIs, and you can be synchronously called from platform APIs that require you to be on the UI thread, okay? The second problem, unfortunately, doesn't have a very easy solution, and I will quickly talk a little bit about it later. So what happened to this picture after Flutter engine people refactored the whole thing? Well, this is what happened. So the platform thread now runs all the UI isolates and handles platform messages. Fantastic. Okay. This work is still in progress. There is still a way to opt out, because there are all kinds of corner cases. But I saw, for example, a few days ago, they removed opt out for Android, so you can no longer opt out on master from merged threads on Android. I think all the platforms support it now, Linux, Windows, Mac OS. Okay. Okay, so back to this topic. We have some random threads and they want to call to Dart. We have in the FFI something that kind of wraps ports around. You can send a message. It works for asynchronous communication. But I said, well, we need to have solution for synchronous calls as well. So we need, as I said, an isolate. You're on some random thread and the native code wants to call you. Which isolate does it use? Well, we can say, okay, use some specific isolate. The problem is some specific isolate might not be ready to accept the synchronous call right now. It might be a UI isolate running on a bound thread, so it cannot accept calls on a specific thread, or it can be just busy, so you need to wait, and it may be not a good idea to wait unbounded amount of time. Use some temporary isolate, but then that does not work either because you are surprised. Each call gets a new isolate. Everything resets every time between calls. All the static fields get reset and so on and so forth. That does not work either. Okay. So there is no good solution. So in the last few slides, I will briefly talk about our thinking, what we think we are going to do and what we are working towards. So if we had shared memory multithreading, just threads and shared memory between threads, there would not be a problem because we would be aligned with the native programming model. But shared memory multithreading is scary and people don't understand it. So there is a lot of code on this slide, but I'll just briefly walk you through it. And I know I'm overrunning, but this is live. So imagine you have this code where there is a cup which is filled with drink potentially, and the drink has volume. And you make a cup, and you somehow share it to another thread. So right now you cannot do it using just normal send of a message because it will be copied. But there is a way to do it. There is a way to write a function in Dart which would actually break the isolation. And the puzzle for you is to implement this. But imagine you know how to do it and you do it. So you share the cup between two isolates running concurrently. And one isolate is a barista isolate which makes drinks all the time. And the other isolate is a drinker isolate which picks up drinks. So it loops until there is a drink that appears in the cup, and then it takes it, drinks it, right? And then there is a question. As you see, we always create a drink of the same volume. There is a 42 whatever liters in it. It's a very big drink. And we expect it to always be 42 in the drinker as well. So can it fail? Can this check fail? So how many of you think it can fail? Because I'm asking the question, so you're like, yeah, of course it can fail, right? I wouldn't be asking. So if you run it on an Intel hardware, it will never fail. If you run it on an Apple Mac or on the ARM64, it will fail. So why is that? That's because it's scary and hard to know all of these details. It's something about memory models of CPUs and whatnot. So never do this. Never write code like this. So, but I think we also cannot avoid it. So maybe we are going to do it. Anyway, I will skip this. We are going to do a small step towards this. Just lay foundation. We are going to make it simpler to write native code or to interop with native code where you want shared native memory between isolates. So not shared mutable Dart state, but shared mutable native state. And for that type of code, we will create ways for you to execute code not in the isolate, but kind of outside of an isolate. You run the code, and you can access some of the static state, but only kind of native static state. You cannot take a list and mutate it concurrently from two isolates. That will not be allowed. But if you have pointers, you can create fields with pointers inside, and you can work with that. You can spawn the threads, and they will be concurrently working on that thing. Okay. We're still figuring out the details. Come talk to me if you want to know more. But I think we will lay this groundwork there, and then we will probably eventually do shared memory multithreading as well. Okay. And now the final thing is, like, I talked all about the native stuff. And you're like, but what about the web? I use Flutter on the web. I know how many of you use Flutter on the web. How many of you use Flutter on the web? Wow, that means I should actually start with Flutter on the web. Anyway, so ironically, so Dart islet design was driven by limitation of JavaScript, but then we dropped the support for Dart islet on the web. So how does it even compute, right? So islets don't work on the web. The problem is web doesn't have a lot of capabilities that we need to implement this. You can use workers, but then certain things get really complicated. And you cannot do the same type of optimizations that we do with isolate groups. Workers are much heavier than isolates in Dart. So we might be able to replicate some of the shared native memory multithreading, which I kind of mentioned, because there are shared array buffers in JavaScript. And hopefully in the next few years, the real solution will arrive through WebAssembly, because there is a proposal in WebAssembly to unlock shared structured memory between web workers, where you can share WebAssembly structures between workers and mutate them concurrently. If that lands in the browsers, we can just do the whole thing easily. Okay, thank you. Find me in the corridor if you know the answers to my puzzles, if you even remember what the puzzles were. Yeah, thank you.
Thanks a lot, Slava. That was amazing. Funny that you mentioned Erlang too, because Swedish as I am, I have Erlang tattooed on my arm. In a few minutes, we will have Roaa up here, but there will be like 6-minute break now. And if you want to go downstairs, we will be Albert having a talk about how to write a button if Material or Cupertino didn't exist. So see you in a few minutes. let's get started with our next speaker, who we usually call the queen of visualizations. No, animations, actually. But I guess it's almost the same thing. Give it up for Roaa.
Thank you. Hi, everyone. Thank you all for being here. I'm here today to talk to you about algorithms. And to do that, I want to first take you back to... My clicker is not working. Okay. I want to first take you back to 1736 in the medieval city of Königsberg. I practiced pronouncing that. And this city you can no longer find on Google Maps. It lay on both sides of the Pregel River, and it had 2 islands connected to each other and to the 2 river banks by 7 bridges. Does anyone have any idea where I'm getting at with this? It's okay. Anyone familiar with the? Okay, good. Cool. So the locals of the city struggled with the following problem. Is it possible to find a route that would walk all 7 bridges and walk each of them exactly once? You can give it a thought and see if you can solve the issue, and this is like a simplified graph of the city. Well, I'm not going to give you a lot of time because it was impossible to solve. It's a problem that has no solution. The locals of the city struggled with this problem so hard they reached out to the famous mathematician Leonhard Euler, who first dismissed this issue as not related to mathematics, but then went back and struggled with it some more, and eventually was able to prove that it's not solvable. And in order to prove that, he came up with he laid the foundation for an entirely new field of mathematics. And basically, he abstracted the problem, reformulated it in abstract terms by assigning a node, what we call now a node, to each landmass and a connection or an edge to each bridge. And this representation allows us to easily see the degree of each landmass. And what this degree shows, or what it allows us to see, is how this problem is impossible to solve. Because you see, if you wanted to enter a landmass via a bridge and exit it via another bridge, technically or logically, each node should have only 2 or pairs of bridges, for the exception of the starting point and the ending point, which can have 1 bridge. So this allows us to see that the problem was impossible to solve. Unfortunately, 2 of the 7 bridges did not survive the World War II bombings of the city, and history eventually solved the problem in a sad turn of events. The new representation now looks like this. You can see that only 2 nodes have odd degrees, and in order to solve it, you have to start in one node and end at the other, but now you can walk this, you can solve the issue. The idea is that Euler's abstraction of this problem made him come up with a new geometry, with a new type of geometry that did not exist at the time, which is the geometry of position. And he was basically one of the first who suggested that it doesn't matter, calculations and measurements don't matter. What matter is the connections in general of items and how they're connected as a network. And that geometry of position became later what we now know as graph theory. So I wanted to talk to you about graph theory today because it includes, like, since the abstractions of those bridges until now, throughout the history of computing, graph theory algorithms, and graph theory helped model different kinds of problems in different domains and provided algorithms to solve those problems. And the timeless nature of these algorithms makes them an interesting topic for today. And
with Flutter as our canvas of choice, we can do some visualization, use some custom painting to see how this works, and just have a unique perspective on this issue. First thing I want to cover is just to cover the basics. We already saw in this graph that we have nodes, we have edges. I'm not sure if you can see my, okay. And the way we represent graphs in computers is going to be like not, we see them clearly, but computers need to see them in an efficient way. So there are different ways to represent graphs in computer science. And we're going to use a couple of them. The simplest one is just a list of edges. So a list of lists of like each two nodes that are connected. This is basically enough. The first list, it basically shows everything about the graph, but it would become inefficient to, for example, access all the neighbors of a certain node. And to do that, we can create another list that is called the adjacency list, and it's basically for like the item at index 0 is the node 0's neighbors, and so on. We will then have a little helper class. Just a disclaimer, the code shown here is like mostly pseudocode or simplified version of the code and not optimized for performance, only to show how you can represent such data structures and see how the algorithms can run. So we're going to have a little helper classes. Our graph has access to the list of nodes, which the node class will have the x and y location of the node, although their like exact pixel location does not matter for graph theory itself. It matters to us because we need to like paint them on the canvas. And we will have some info like, is the node visited? And if it's visited, we want to see from which node we came to this node via an optional previous node parameter. And now painting the graph is just a matter of looping over the nodes, drawing a circle in a custom painter, looping over the edges, drawing a line between edges. And when we have a node that had a previous node, we can draw an arrow from that node to this node. And with something like the adjacency list helps us also access neighbors node of certain nodes. So when we have this graph, for example, we can visualize easily how nodes are connected and which neighbors they have. And this basically sets us up for what we're going to do next, which is graph traversal. The process of walking those bridges when we're trying to solve the issue of the city is what's now known as graph traversal. And you can think of it like the application we're using today is search algorithms. And for search algorithms, you're basically searching for a certain node in a certain graph. And to search for a node, you logically want to visit all or some nodes. And visiting those nodes in a certain way is a graph traversal algorithm. And the one we're going to start with is depth first search. Most of you might be already familiar with it. It's just the idea of like visualizing it on the Flutter canvas would be a good start. So the pseudocode of this algorithm goes like this. We want to visit the first node of the graph, mark it as visited, or sorry, add it to a stack, mark it as visited, and then as long as the stack is empty, we want to remove that node and then visit all the neighbors of that node. And talking about this like this is just not practical. So we can just visualize it on the canvas itself. We have this graph, and I'm choosing a grid graph for, I have an agenda for this, so you'll see why later. But basically in this graph, all nodes are connected to the nodes around it in each cell. And if we start from here, and we have our goal now is not to search yet. For now, we want to traverse all the nodes. And we can see that, for example, the first step in the algorithm is just to go to this neighbor to the neighbor of this node and add this node to the stack. I hope it's clear. Okay, I tried to make the font as large as possible without ruining the visual effect, but yeah. We then, after this step, we visit another node, and then another, and you see here, this node has all its neighbors visited. So ideally, if we didn't have the stack structure, we would not be able to continue. So with the stack, we can then return to the last one. Oh, sorry, this still had a neighbor. Okay, it's now no neighbors. Now we can use the stack to return to a previous node until we find a node that still doesn't have a visited neighbor, and that is this one. And then we basically continued the traversal of the algorithm. So basically, we can also run it like this. And now I want to go over how I went from like just simply painting it on the custom painter to animating it in this way. And the basic idea is having an abstract algorithm class. Again, this is like a very minimal version of the code. The algorithm class has the internal state of the algorithm and implements a step function, which is just a single step of the algorithm. Because usually you have an algorithm, and we saw in the pseudocode, it does the whole thing in a while loop, and we don't want that for our purpose. We want to do each step of the algorithm in a separate time. And to do that, we went about it this way. And for example, for the DFS algorithm, the step function can do stuff like find the next unvisited neighbor using the adjacency list and populate the isVisited and previous node parameters. And on the widget side, we create a ticker to see the animation in action. And simply on the onTick callback of the ticker, we call the algorithm step function, and we achieve the simulation that we saw before. Now, why did I do it in a grid? So let's see what happens if we have the following grid and run DFS on it. And done. Does anybody see this as something familiar? You can shout out. Yes, that's right. So one of the interesting applications of DFS is maze generation. So basically, if you were to turn each node to just a rectangular cell and like overlay this graph and just press play, you can generate a maze. So this way, we went from visualizing what DFS does to just creating a simple maze. But creating a maze and not solving it is a bit incomplete. So to do that, we will go into another algorithm, and that is breadth first search, which is the sister of depth first search, but the algorithm goes in a different way. The goal of the algorithm is to, instead of like traversing deeper and deeper and deeper into the graph, is to visit the neighbors of each node on their own and then expand from that. The visualization goes like this. I am at the center node, and I'm going to visit each node once and add the nodes I'm visiting to a queue. So in the previous algorithm, we used the stack. We first, and I'm not gonna, it's gonna be wrong. So with the stack structure, the first one we add, we pop, and in this case, we need a queue, because the first one we added to the queue, which is number 18, or 12, sorry, we go back to it, dequeue it, and then, okay, I needed to run the step by step. Okay, so we visit all the neighbors, and then visit the neighbors of the first neighbor we visited, which is number 6, and so on and so forth. So we can see them better visualized side by side, like this. And you can already see the name by the arrows represented in the simulation. And this just shows like it's expanding from the center or it's going deeper and deeper. And now we can use them to solve that maze. To do that, we're going to make a simple adjustment on our algorithm class and add a find step, which instead of traversing all the graph, we provided a goal index node, which is usually the last one in the graph for the maze. And we stop the algorithm when it reaches that step. And we can return using the previous node property on the node class. We can return a list of indexes that were the path from the starting point to the goal point. And that looks like this. So it's looking for our end. We can see the graph overlay. It's not very efficient, but it will do it eventually. And we can also use DFS for solving the maze, but it's better to see them side by side. We can make them have a little competition. Yeah, that's going to take a long time. No, okay. BFS1. I mean, it makes sense because DFS goes into a lot of deeper levels. We can go into a little bit of the creative side and take it a bit further and use something like estimating the distance and assigning that distance a value to the hue color value of the cells and making it very, very, very small. I tried to do it like a 5-pixel thing. It crashed, so I did not want to risk it for this presentation. And yeah, this is going to take a long time, but that's it from me. Yeah, thank you very much.
Thank you, Roaa. Always so pretty slides. I love them.
Any questions? Or while this maze runs? Oh, no, it's off. Okay.
Oh, it's still running.
But it's...
Oh, right. Yeah, any questions? None at all.
Okay.
So, let me check the schedule, because I forgot this was a quick talk. Now we have... now it's actually lunch until... But the lunch is not served yet, but you can go out and hang out in the exhibition area. And then at 12:05 we will have a slides karaoke, which is a lot of fun. It is like you get random slides and you have no idea what they are, and you're going to stand here and present them. So if you want to do that, you can talk to Mangirdas, yes. And he looks like this, stand up and wave to people. So meanwhile you're eating your lunch, you can watch that if you want to. It's just a little fun thing. All right, see you after lunch.
not yet. Yes, yeah, it is.
All right. Are you ready for a not serious talk for once? And of course, we have Mangirdas with us, our Flutter meme god, and he will run something called Flutter Decks AI Slide Karaoke, or whatever you wrote to Google to get sponsorship to come here.
It is. No, I paid for everything, so don't worry about it. First question: who was there last year, watching the same thing, like slide karaoke? Okay, half of that. So, for those who remember last year, and for those who don't, we had slide karaoke. So we have 4 presets of presentations, and random speakers who have never seen those presets, and they just presented them. Now we are lucky enough that over the year, the AI improved a bit. So now we can actually are not limited by the number of slide presentations because we will generate them on the spot. And that's the beauty of AI. And I hope that it would make sense, the presentation itself, but also it would go downhill and the speakers will be lost at some point, because that's the goal of all of this. Slide karaoke, we'll try to keep it short, so there will be 10 content slides generated for you, so 12 in total, because there's a title slide and thank you slide, obviously. And let's keep it about 3-5 minutes per speaker, so based on the time constraints, we should make maybe 3-4 presentations. And the fun part is that I need volunteers who want to represent. So who want to start? I know that this beautiful guy sitting in the second row, on the very left on my end, he didn't get a chance to present last year because he was like the 5th person and we only have 4 slots. So give a round of applause for Renan. And I should do a little interview thing. So hello, who are you? And how are you related to Flutter?
I'm not related to Flutter, but I've been working with it, and I work mostly with UI stuff, games, this kind of stuff, yeah.
So games could be a keyword, right? Any other topic suggestions that could fit this this person? Capybaras. You could talk about, okay, capybaras. So let's say capybaras. Can capybaras, let's see, what could the game about capybaras look like? How does that sound? The mic is yours.
All right. A new game about... Really? Today I learned. Because I know capybaras from Brazil, and it's capivara there.
Let's hope nothing fails. But it's software, so it could happen. Also, since this is technically a talk, so what's happening in the background? So this whole thing is run by Vertex AI Logic, not Vertex Firebase AI Logic, sorry. Oh, I can, yeah, so AI, Firebase AI Logic, which is a pretty new thing. So under the hood, there are 2 models running in parallel, one model for generating text for the slides, and the other model, which is like, publishes a lot of requests, like 7 or 6 parallel requests to generate images. Everything is then combined, and by using the best Flutter presentation framework, Flutter Deck, it happens that there's a presentation. And we can launch it and wish Renan a good luck. This is your clicker. Enjoy.
Thank you. Thank you. Okay, let's present you introducing, let me make the Apple power stance. Introducing Capybara Quest Battle Deck. So, today we're launching a new game. It's called Capybara Quest. And it's here to revolutionize gaming in total, because we need a revolution in mobile game. And yeah, it's very addictive, more addictive than crack, and may cause extreme relaxation. this sounds wrong, mate. All right. It has amazing features, and yeah, capybaras are amazing. So if it has capybaras, it's amazing, and our play engagement metrics are quite terrible, actually. Yeah, I mean that's not good. That's worse than Bitcoin price. All right, let's go. Yes, any questions about a game about capybaras? Yeah, but yeah, okay. Questions. If a capybara could paint, what color would joy be? If you could paint, what color would joy be? I mean, if you could paint a color for joy, what would that be for you? Cyan. Anyone else? Yeah, pink. But for me, it's brown because the color of capybaras. Yes. Does the virtual sun ever set on the digital swamp? Yes, if you program like that. It means it's about game development. We're going to talk about this later in the afternoon. And why are my socks always mismatched after play? Man, I think that's a you problem, AI. Yes. And another question, what's my favorite things about capybaras? I mean, they're happy and their meaty are delicious, really, really. Wow. So yeah, you have to be strategic how you eat your Pringles or Lay's. What's best, Pringles or Lay's? We should have that. Pringles all the way, Pringles team. This Flutter Friends is sponsored by Pringles. And yeah, now let's do a team building. Now, let's go. Everybody turn to your person next to you. No, your neighbors. So your neighbors could be someone on your side or something, someone behind you. So yes. Agree on your spirit vegetable. So, all right. So both of you that you're looking at each other now should agree on a vegetable and present the vegetable. Someone want to present a vegetable? Potatoes. Is that a vegetable? I mean, what's a vegetable? Potatoes are? Yes, they are a construct from the government, just like capybaras. Just like birds. Yeah, birds are not real. They're drones from the government. And let's see, let's analyze the failures. All right, words of wisdom. The squeak of a rubber duck is the silent roar of a cosmic truth. George Washington. Really, I think this really feels like a TED kind of talk, you know? Just lots of nonsense. And let's talk about advanced culinary. We already covered the capybaras parts of the culinary. What's the optimal ratio for a toast? Is 1:17. Great, I can work with that aspect ratio. Always pre-warm the spoon for maximum jam dispersion. That's new. I want to try it. And never underestimate the power of a perfectly symmetrical sandwich. I mean, it's not going to be symmetrical after the first bite. All right, let's talk about reality. We already learned that birds are not real, capybaras are not real, and tomatoes are vegetables that are not real. Thank you, I guess.
Thank you. The best presentation about gaming, I suppose. My question is, who is next? I promised this to Pooja, so welcome here on stage. Yeah. Yeah. Hello. How are you today?
I'm doing fine. I'm just still working on my first slide of my presentation.
Okay, that's nice. So, what's your hobbies outside? Outside overworking.
Sleeping.
Good keyword, sleeping. Yeah. Can someone name a place where Pooja likes to sleep? Paris. Sleeping in Paris. Nice. It sounds like a song name, but I won't say that first name. But sleeping in Paris, right?
It's sad that I'm sleeping in Paris, though.
So the interview should going. It should take about 20 seconds. That's what she said. So let's say, what are your plans? You have a workshop. Yeah, Pooja is there because she has a workshop tomorrow. Do you want to? Yeah, pitch it. Why not?
Yeah, the workshop is about how you can build. So we have this tool called, which is kind of cursor, but
Oh yeah, it was interesting. Let's go. Give a round of applause.
Okay, so I want to introduce you about this very fun activity, which is sleeping in Paris, and it's a adventure. As you know, Paris is a city of love, light, and naps that you should do in front of the Seine River because it reeks of shit. And the secrets to truly mastering Parisian slumber, I'm still figuring out, so nope. Yes, the art of Parisian rest is basically you should sleep near a croissant, and you should pronounce it a croissant. So otherwise, the Paris government is not gonna let you in. And the best part about sleeping in Paris is this: caffeine catapult, or whatever that is pronounced. Well, if you were in Paris, apparently, I do not know, but you can have coffee, or you cannot have coffee after 12, I think. I don't know. So definitely have it before so you can sleep in this caffeine, whatever. Reclining after launch. Okay. So one must achieve optimal recline. Yes, probably in the bed. And I'm also like figuring out why I chose this topic. So I'm really regretting my decisions at this point. But gravity-defying pillows are now a market trend. Apparently, there are some pillows that also vibrate. Do you know that? Did you know that? Yeah, there are pillows that vibrate. I think that's amazing for great sleep. So it'll help with atmospheric pressure zones of whatever comfort. So team building exercise. So let's do that. Okay, the silent squeeze. Pass a phantom croissant. So please, if you have an imaginary croissant, please pass it to your neighbor. Hold hands with your neighbor while you're holding the croissant. Silently contemplating the journey of a pigeon. So please fly while you're holding the croissant. Achieve collective dream state synchronization through sustained eye contact. Please have some eye contact with your neighbor while flying and holding the croissant. I don't see eye contact. I'm very serious. It's Paris, guys. You gotta fall in love. If I see that one guy who's definitely falling in love, so I think that the purpose is now complete. As I said, the pigeon gaze. Again, look into your neighbor's eyes while holding the... Nice. And this is the motto of life. When the linen calls, one must answer, even if the question is, why are you wearing a swimming cap indoors? I don't know who asked this question, but that's the motto of life. Apparently Oscar Wilde, so yeah. And then you have something, a solution for you who likes to sleep, and apparently in Paris, because you have money. Traditional horizontal sleeping is now considered inefficient. All right. I mean, do you know about Ryanair actually has like a standing seat where you can sleep vertical? So I think this is where it comes from. Vertical napping conserves floor space, allowing for more indoor fountains. Yeah. Optimal blood flow, because obviously you are standing, and if you like to do headstands, I think that may work better for your blood flow. So you can just do a headstand. I can't try, but you can do a headstand and then sleep vertically, and that's a solution. When you sleep in Paris, you dream of croissant, and that is, I'm hoping, not the land. Because the true Parisian sleep dissolves into pure thought form. It obviously was written by an AI. And you wake up only when your spirit guide nudges you with a baguette. And congratulations, you're now officially the master of the Parisian non-sleep. And I'm hoping that is the end of the talk. Thank you so much.
Thank you. Yeah, it was amazing. And since Lucas is not shying me away from the stage, we have some time for one more. Really quick, really fast. Volunteers. I do not want to be picky, so whoever comes here first is presenting. Okay. I see a person almost fumbling. Oh, you shouldn't see my desktop. Okay. Hello, introduce yourself.
Hello. I'm Jakub, and as I already did some sporting, I think that should be the topic.
Okay, so some sporting. Nice. Yeah, I have one. I'll just type it. Right. So feel prepared.
All right. I don't know how to prepare for that. I should do push-ups or... All right.
Yeah. From the name, it sounds like a local guy, right? Or not? Where are you from then?
I'm from Czech Republic.
Czech Republic. Nice. So, do you like the Swedish beer?
Oh yeah, I tried.
And now, be honest.
It's expensive.
We all see it. Yeah. Yeah. I saw what it went for. Yeah, it is ready. So, good luck. And let's see what the topic is actually about.
All right, so welcome everyone. Here we have some amazing topic. So let's see what I have prepared. So, what is a professional fumbling? A revolutionary new sport with participants earn points for deliberate yet graceful loss of balance. So, I hope later on we all get to trying it a bit, so get ready. And the emphasis is emphasis is placed on dramatic recovery and unexpected drop of everyday objects. So I really think everyone is familiar with this, like after drinking some beers, especially in Czech Republic, where it's much cheaper than in Sweden, you know. It's more common, but I really assume that everywhere around the world it's common. Originating in competitive banana peeling, it has evolved into a global phenomenon. So it all started with all those crazy video games where it's a peel on the ground and, you know, everyone just slips on it. So it got to a real life as well. So yeah, it's sports for everyone. You don't have to be anywhere near talented. Actually, the less talented you are, the better. So yeah, everyone can compete in that. and it should look something like that. If you don't have the flying rag, don't worry, you don't need that as well. And yeah, somehow, don't know exactly how, but our great team behind that managed to find the deep sea toothpaste, and well, it has some plankton because why not? It's from the deep sea. So if you have, or if you want to have that super shiny smile as this diver, then should use our toothpaste from deep sea, and it's definitely eco-friendly and all that stuff. And let's do some mastering the trip. So the invisible banana peel technique, a sub to shift for weight for maximum impact. So I believe we should try it out, or it will come up later in the slides. As I, oh, all right, show us. All right, so you have to imagine there's a peel, but it's invisible. So then we have advanced technique, which is coffee split cascade. A control multi-stage. All right, so I don't have any cup with me, unfortunately, so we will skip that one. And then the Brett's cannot fall. That's for more advanced, and it's our top research, and I'm just presenter, not the research scientist. So I won't do that, but it's really amazing. Yeah. So here we go with the team building. I think you should try like the banana peel. It's like really good for beginners, and like let's start with it. So the exercise is following the collective wobble. So step 1, everyone stands up and close their eyes. So let's go. All right. There's still some people sitting, so try to stand up. All right, and now gently sway from side to side, imagining you are tall, slightly depreciated, inflatable tube man. So just imagine you are the Michelin, you know, and sway around. All right, sway more, guys. Come on, you are in the front row, you know, everyone see you. Okay, great. I think everyone's doing so well. I think we should estimate the sport and like maybe, I don't know what guys do think, but I think Summer Olympics would be better than winter. Even though it originated here in Sweden, so maybe Winter Olympics could be as well. And yeah, the essential gear for fumbling is this crazy, I don't know, like it should be an inline skate, I believe, but it's a bit weird. So yeah, if you want to buy this, we have some sale. You can contact me later. And yeah, some inspirational, deep meaning. True progress isn't about avoiding the fall, but about the elegant trajectory of the descent. Oprah Winfrey. So yeah, this is our deep meaning and beautiful stuff. I let it sink for a minute with you. Yeah, all right, we don't have that much time, so let's go. Global Fumbling Federation. As I already mentioned, we have like some great products, and we're planning to go for Summer Olympics, so we're also preparing some federations so we can compete outside the Olympics and those games. So if you want to join, you can, again, contact me later. And Fumbling in the Kitchen is the best team that we like to do, because, you know, like the banana peels usually appear in the kitchen. So the souffle collapse, a perfectly timed implosion for theoretical culinary effect. So yeah, it's amazing. The pasta avalanche, strategic tangling of spaghetti for grand reveal. That's what happens to me usually with spaghetti. And elevating forgotten ingredients to found art through accidental placement. All right, so yeah, some AI bullshit. So let's go. And yeah, beyond the mat. So yeah, our sport is super attractive. Even penguins try to do it. They are pro at that, you know. They have like super tiny legs, so they walk just a bit, and So to move faster, they usually use that for the sliding part. So they start with banana peel and they slide away, and that's all. And I'm gonna slide away as the penguin.
Thank you. Yeah, keep an eye on him. I think that's it. Yeah, we are a little bit out of time. So this is a software after all. Probably I'll just open source it, maybe with some kind of, I don't know, some explanation text of how it was made and how it could be improved. Or maybe that would become my first, premium product where you need to buy a subscription or whatnot. No, I'm joking. Of course, that's open source. Yeah. Thank you all for being there. And now I think we'll move to the more serious talks, and I hope they will make more sense than these ones. Thank you.
Thank you so much. Give it up for Mangirdas. And now we have a few minutes break until 1:45, and we will have Remi on stage here talking about state management, of course. And on the stage, studio stage downstairs, we will have Is Your App Faster with Const? See you soon. start when I get seated. All right, it's time to start our next act. I hope you enjoyed lunch and the slide karaoke. And if you've never seen Remi before, which I guess most of you have, he's the author of Riverpod. But what a lot of people don't know is that Remi thinks that Star Wars only is mid. Give it up for Remi, and he's going to explain to you why state management is hard.
I forgot I said that in the video. Hello, Stockholm! Yay! I've heard that chocolate is decent here, so if you have any tips, I want to know. The future of Flutter is dependent on this knowledge? Yeah, please tell me. So here, I'm going to tell you today about state management, just to change, because, you know, that's not the usual topic I do, you know. Just kidding. So for this time, I want to not necessarily talk about my packages, I want to talk about state management kind of like as a broader topic. More specifically, I want to respond to this kind of comment. You probably saw those across social media here and there. Like, just use set state, and you can replace set state by pretty much anything built in inside Flutter, like inherited widget, value reasonable, change notifier. You know the drill. So I'm here to try to convince you that there is actual value in adding packages and not necessarily doing stuff by hand. I know for some of those it's sound obvious. I know for some of those it might be a bit controversial. So we'll see where it lands. And you'll have to forgive me because this talk is going to be very boring, and we're right after lunch, so hopefully nobody sleeps by the end. Right, so why do we care? One of the reasons state management is a bit particular is it might not sound obvious at first, but state management is a much broader scope than what we typically talk about. We tend to talk about state management as just like business logic, like change notifier, observable. You make a custom class where you add a listener and you remove the listener, and that's it. We've done with state management. I feel like it's a bit relative. Overall state management is like many different kinds of things. And there are many different kinds of state. Typically, for example, one of them is something we call app state. App state is kind of like your global, quote-unquote, state. It's where you share state between different components of your application, between different screens. That's what typically you will implement with packages such as Riverpod, which you may know or not, or like block, whatever. Those are business logic stuff, kind of packages. But that's not the only kind of state management. For example, you also have component state, and it's also a form of state management, but less mentioned like so usually. This one is more about widget-specific state. So like, for example, say you had a screen where you had two different counters, where you have a counter widget and you instantiated it twice in the UI. If it's component state, usually if you were to increment one counter, it wouldn't impact the other counter, if that makes sense. Those are independent. That's usually a sign of component state. And for those kind of states, you'll have packages like maybe Flutter hooks, if you're familiar with this, to like help deal with broad controller types of objects. Maybe you have some animation packages to help with transitions, whatever, like stateful widget-specific stuff, if that makes sense. You have another kind of state, which is persistent state. That's typically your on-device kind of state, like your database. Basically, the application is killed, but there's still this state stored somewhere, whereas the other previous states were like in-memory stuff. And persistent state is independent from app state and component state in that they all interact with each other. Like, it's not like persistent state is specific to app state, because, for example, it can interact with component state too, in the sense that it's quite common where when you build an application and you kill the application, you want to implement it such that when you reopen the application, you go back to the same page as before instead of going to the home screen. That's a form of persistent state, even though you don't necessarily have to deal with the database manually. And so here you might be tempted to use packages like, I don't know, Drift, SQLite, there are many of them out there. And yet another kind is like server state. So here it's not necessarily on-device stuff, but more about remote stuff, whatever your server stores. So here you can deal with many other packages once again. Like some of them may be Redis if you do some backend logic, but also it depends on like if you use Flutter, we don't necessarily do that, but maybe if you do some React stuff, like web stuff, you might do something called server-side rendering. And then depending on the server-side rendering framework, sometimes you do SQL logic straight up in the on-press of buttons nowadays. That's a thing. Not too much in Flutter, but whatever. Also, it's a bit similar to if you were to use Firebase, where Firebase kind of like moves the logic for dealing with a database in the client. And so it's a bit similar to doing SQL queries directly in the client. That's a form of state management too. And then again, also, for example, if you were to use Firebase, you might be downloading extra packages on top of Firebase. Like, for example, you might be familiar with something called the Firebase ODM, which is a package maintained by Google and Interface to wrap Firestore APIs to make them type safe. Again, there are lots of packages out there. And so, hopefully, by mentioning all of these kind of states, you can probably start thinking about how state management kind of represents a big part of the application, the programming world. Here, there is a small pie chart, or camembert chart, if you're French. The idea is here, it's rough a little bit, but it's supposed to represent how much time you spend on different topics. I would say, in general, you kind of tend to be 50-50 between implementing the layout, like you have your designer which send you a Figma file, and then you clone that stuff, making a static page. And depending on how crazy your designer is, you may have to implement funny animations and stuff like that. That may take some time. But if it's just a static page, it can be very simple to implement. And then there is all this logic layer, a bit like your business logic, but also navigation, stuff like that, that can be also tricky to deal with. That takes a huge chunk of time. You have to deal with all the testing related to that and stuff like that. And so dealing with the business logic tends to take a huge chunk of your time when you do reprogramming. And then the other part is like things like documentation, whatever. And so the thing is, when you have a bug in your application, usually it's on the business logic side of things. It's not always the case, but it's usually where it is. Like you forgot to synchronize some state, like you incremented a counter, but then the display string that's combined from the counter and some other stuff, you forgot to edit it. That happens. Whereas there are some UI bugs, like maybe overflow and stuff like that, but we are quite fortunate with Flutter. The way Flutter is architectures tend to reduce the impact of most bugs, if that makes sense. Most of the constraints and stuff like that remove a lot of corner cases around layout issues. So in the end, yeah, most of your bugs tend to be on logic sides. And so the key here is any small improvements that we make on how we implement the logic, since it's such a common topic when we do programming, that will have a large impact over the entire development process. Because like it's going to impact you everywhere. Also, I feel like when people say just use set state, they kind of like lie to you, because they never really just use set state. They say they do, but they actually do something else. You see, when you make an application, you don't just increment a counter and that's all. You have to do some testing, you'll do some network requests, you'll do some stuff like that. So when you do 2 network requests and stuff, you'll want to reuse the error logic, the error handling logic. You might want to implement some form of system to deal with loading states, to have maybe some retry mechanism, like you want to store you cache the network request offline on a database to restore them, stuff like that. There are all these ceremonies that you tend to do around applications, which people who say just use set state don't talk about. They say we do an observable and that's about it, but they end up actually implementing all those seizures here. It's just that they end up implementing those by hand, if that makes sense. And that's great and all. Like, it works nice, but in the end, what they just did is, make normal package. So instead of Riverbud, it's your company, yeah. But Riverbud, but worse, I mean, I think so, at least. I mean, we've all been there. Be it like, it's not necessarily about making a package. It's a common trend with development is we see a bit of code, we don't like it, we decide to do it ourselves. Like, we think we can do better. And maybe we can do better. But the thing is, usually when, the way it starts is we don't necessarily have the full context around the problem. And we start working on it, and as we work on it, we realize, hey, there was this edge case around the application, and I didn't think about this before, and I have to do all those corner cases when we implement the feature. And we end up re-implementing pretty much the same thing as before, just with a new name now. And we tend to be happy about it. The main reason is since we wrote the code, we are more familiar with it. But it's not necessarily better in a sense. It's more we mastered it just by coding, if that makes sense, instead of reading documentation. So in the end, one of the key points when you use packages, not necessarily state management, but packages as a whole, is view them as a way to solve problems. Like here, for example, this is an example I use in the Flutter hooks documentation, which is one of my packages. It's not necessarily here to recommend using Flutter hooks, just as a simple example. I know Flutter hooks is a bit controversial. So here, this snippet here is just using plain stateful widgets, where we try to do an animation with plain stateful widgets using the base native APIs. I'm not talking about here Toon Animation Builder and stuff like that, those are extra layers. Just you create an animation controller and try to do animations with that. So here we start with a simple stateful widget, nothing special so far. We pass in a duration because the animation can be controlled in terms of duration. So this duration might change based on some parameters. We make the state, usual stuff. Oh, wrong line. I was supposed to highlight this thing here, the ticker, whatever. So yeah, since we're doing animation, sorry. Since we're doing animations, we have to use something called single ticker provider mixin, something like that. It's under the red line, so we can't read it anymore. And I don't know how to remove it. But yeah, we have to use this mixin. Then we do, and everything is under the red line. Nice. Can I remove it? Okay. We create an animation controller. Nowadays we have the let final keyword, so it's we don't need an init state, but before we used to need an init state, not anymore. So we create an animation controller, pass a vsync parameter, which is obtained from the mixin. Pass the duration. Oh yeah, there it is. Then we need the did update override because the duration might change, so we need to handle cases when the duration changes. So we need to update the duration on the controller. We need to dispose the controller when the widget is destroyed, and then only then we can start with the UI. So in there we can use maybe an animation builder to pass the controller, and finally build the text. Which is final, nothing too special, and there are ways to make this simpler, like I mentioned with Toon Animation Builder. But here, like for example, this is what Flutter hooks offers. So the idea is instead of stateful widget, you would subclass hook widget, which is a custom kind of widget for hooks. You still take your duration as parameter, but instead your implementation changes here. Now we can just obtain the animation controller using a single line. We call use animation controller, and we just pass iteration. And it does automatically all the logic that we did previously in the previous slide about, creating it, updating the duration when it changes, that's automatically handled. Disposing it when the widget is destroyed, the controller is automatically destroyed. And then we just pass use animation, which is to listen to the controller. That's the equivalent of like animated builder or like listenable builder. It's optional. It's just a funny one-liner. So the idea here is Flutter Hook wasn't necessarily trying to reduce the verbosity here, although the code size has reduced dramatically, but that wasn't the primary goal. Instead, the goal was when we were writing animation controllers by hand before, there were a few things we could do wrong. We could, like, for example, forget to update the duration, forget to dispose the controller. That's not necessarily hard to do by hand, but that can be, it's one extra thing you have to keep in mind, and it's one thing you can easily forget, and it's not necessarily obvious when you do a pull request and you read out the code that you forgot to dispose it. Sometimes the widget can be very long, and it's tricky to spot one missing one-liner. And so by slightly shifting how we implement the logic, we were able to refactor the logic in such that we could more naturally handle, have a better default behavior, if that makes sense. We naturally handle all these the edge cases. Also, I would encourage thinking about packages not as something you could fork yourself, but also as kind of like extra knowledge you can download from the web. Because like you see, when you download a package wasn't just made once and then forgotten about. They tend to be maintained over multiple years and after a lot of experience from them. And they tend to be versioned over time. Like Revbot started with a very different API in the old days, and every year something changes a bit. This happens through natural feedback from people. Like they say, here, this is in this case, this API sucks. How do we do things better? Or this is unintuitive. This is bugs. This doesn't handle those cases. That's a lot of knowledge, a huge database of knowledge, which if you were to start from scratch again, chances are you will miss a lot of those information, and you'll end up re-implementing the same issues that were solved over the years. Because like you don't necessarily think about those naturally. So you'll end up losing time hitting the same walls again and again. Also, one thing about state management is that it's a bit misleading in the sense that nothing is individually hard. The challenge is not like catching errors and logging it. Everyone knows how to do a try-catch and then a print statement or whatever. The challenge is doing everything together. We have a list of a lot of different features, and we need to combine them together and in a nice way. And the challenge is that when you implement a reusable feature for one problem, it might be incompatible with a different way of implementing a different problem, if that makes sense. So here is a trivial example. Like say you have a reusable function to handle errors in a callback. Because like maybe you want to have some form of result object to deal with errors explicitly instead of having uncaught exceptions, which is a common pattern. And so you have this handle error function which converts some piece of unsafe code and convert it into safe code. The thing is, even this simple piece of code here has many extra stuff you need to think about. Like, for example, what happens with the error here? Do you ever report it to your Sentry or something like that, Crashlytics, whatever? Because like it's very easy to, with such a code here, is if you don't realize it, you're effectively silencing the error, and the error doesn't appear anywhere anymore, even though it's uncaught still. sure, your UI will be able to show the error, but nothing will appear in crash statistics. So maybe users will see an error, but you won't know about it. Then you need to think about how does it combine with, like, say, some form of retrying system, because maybe that's a different function somewhere which has different expectations. Also, it's a bit dumb, but here in this example, it's expecting a synchronous code. But then if you were to try and support like futures or stream, these under-error functions, you can't use it anymore because like you need to await the future for it to catch errors inside the future. There are many edge cases like that. And there are some that are even more obscure than those I mentioned here. It's really easy, devil is in the detail, like in the title. So like here is a simple example. You have a future and you do a future.then, and inside the future.then you pass a function, something we call a tear off. We just pass the function without a closure. And then in that function, somehow there is a bug, there is an exception. So yeah, we just pass the function like that. We end up with the following stack trace. In the stack trace, you can see the map state function. But we don't see anything else. We don't see where the future was created. And maybe map state was used in many different places in the application. And we don't know which specific part of the application was the problem. The thing is, if we change the code to just, instead of passing the function directly, we do a closure. We create a function which invokes the function. And we run the same code. Suddenly, this stack trace is more interesting. As you can see, we still see map state. Where is my mouse? Here. We still see map state here, but we now have the main information. And that's a tiny chain of code, but that has a big impact on debugging. And you wouldn't necessarily know this ahead of time unless you encounter this issue and try to solve it by hand. So in the end, also one of the challenges, if you try to do things by hand, usually we tend to forget how much time it takes. Like for transparency, I've been maintaining Riverbot for like 5 years now. I've still been spending like the last month I've been working full-time on Riverbot, even though it's still 5 years old, like doing bug fixes, documentation, stuff like that. You have to keep this in mind. It's not like a one-time thing. When you write your code, when you write your pseudo package, you'll have to maintain this over a long period of time, and it will delay features if it will delay feature, yeah. And also, yeah, some people do compromises. Sometimes we know for better quality code, like it would be better to have like a nice README, a nice stuff like that. But people tend to cut corners when they bake a custom approach, because nobody likes writing docs, right? I don't do good docs, so yeah. Another thing important factor here is you lose out on the community. It's an easy to ignore point, but when you use a package, it's not just solving your problem. It's also helping you in the future too in different ways. For example, you can ask ChatGPT about this specific bug you have in your application, and there is a chance that if the package is old enough, ChatGPT will know about the package. Whereas if you were to do something by hand, you will have to hope that the context is big enough for ChatGPT to start understand your app. Same thing, if you have a bug and you can go on Discord or on like Stack Overflow, on Twitter, something like that. You might be able to find help for your package, or like maybe some blog posts here and there. Or if the package doesn't fully solve the problem, chances are, if the community is big enough, there are some extra bonuses from other community members available on pub. Like for example, if you use Riverpod, I'm aware that there are some packages to make custom providers observers to help with logging providers and stuff like that. You could download extra bonuses. And last but not least, when you hire someone, when a new team member joins the team, if you tell them this application was built with block or with Riverpod, they kind of already know what to expect. Whereas if you tell them, I've built it using just set state, then nobody knows what to expect. It could be just a very messy application or like a very tidy stuff, really depends. And so it increases the onboarding process and stuff like that. Also, it depends on the package, but you tend to lose out on goodies that you likely wouldn't implement if you were to do stuff by hand. Like, for example, in the case of ReviewPod, it comes with many different things like custom warnings, refactors, some snippets here and there. Like here, this is an example about when there is a slight bug where you forget to specify a dependencies parameter. There is a quick fix for it. Or like, there is DevTools for some packages. There is one for provider. I've been working lately on one for RiverPod, finally, I know. Yeah. That's not the picture, I know. Soon, we'll see. So chances are, like doing this kind of content requires very specific knowledge. Like maybe you need to deal with analyzer, maybe you'll need to deal with DevTool plugin mechanism. And chances are nobody who just worked on the app knows that. It's very niche knowledge and very time-consuming, very complex. So you likely would just skip on it altogether. Overall, I would say, yeah, sorry. You might then ask yourself, when should you maybe start to try and consider doing stuff by hand? So it's not like you should never do things by hand, because I mean, I made the packages, so I started somewhere. You know, so maybe someone in the audience will make the next popular Flutter package. Who knows? The thing is, you need to be aware about the potential challenge you will face. First, you need to be a little bit confident about being able to do something better, because I know when we usually start doing stuff by hand, we feel that we can do better, but it's important to know that we don't necessarily have the full context about the problem. So make sure to investigate whether it's worth spending so much time on it. If you're confident, go ahead. Also, make sure to not be pressed by like time. If there is a feature that's very important, you should know that you'll be delaying it by possibly a bunch of weeks, if not more. I know it's very fun to work on packages, but that's very time-consuming too. And so you'll also most definitely do bad stuff the first time. Even here with RiverPod, I mean, I first started with provider, and then I made RiverPod. But even then, you probably don't know, but I probably made like maybe 20 different packages. I never published half of those, but I tried those. It's just a random example about how much effort it can take to come up with a satisfying API. You can try something, then find out that in one important case, the API that you tried actually is horrifying, and so you give up on it. You do another one, but then that other one also has another specific edge case, and so you scrap it too, and you end up with 20 at the end. And so yeah, lastly, one of very crucial point is you really need to be able to not just do it once, but maintaining it over time. Because the issue is you will find some hurdles on your way. And so you need to be conscious about the fact that it's not just, if there is a bug, if there is something that's inefficient with the way I've implemented my custom package, I need to be able to spend the time not just today, not just block the current sprint, but maybe block one of the upcoming sprints, if that makes sense. And so for that, I would encourage to think about something I call the rule of three. There's probably a better name for it, I don't know. It's just try to not necessarily reinvent the wheel day one. Only start doing so when you maybe encounter a pain point like 3 times about so. Like, for example, say you want to make a paginated API, and you find that the way Riverpod deals with it is not ideal. The thing is, maybe it's possible that your specific page, your specific constraint for one view made that Riverpod wasn't ideal in that case, but that for the other pages of your application is decent. It's just that specific page. But it's also possible that most pages of your application have the same issue, and then at that point, it definitely makes sense to simplify things further, to try and re-architecture things. The point is, if you try to do it too early, chances are you'll waste time for nothing, and you'll complexify stuff instead of simplifying stuff. Which kind of joins to the next point, which is don't over-abstract. I've seen many people say we should not tightly couple our application with a specific package, and so whenever I use a package, I make a custom interface to hide the package from the application, so that I can possibly swap the package out to a different package. That's probably something you've heard before. For me, that sounds nice on paper, but I would say that in practice, this never really happens. First of all, nobody really changes the package for a state management library. Even if you do, chances are whatever interface you built is not going to be designed for the replacement package, if that makes sense. Because like, say you first made an interface for block to hide block from your package, but then you want to switch to Riverpod. Riverpod is really different from block, and so chances are your interface doesn't allow an easy transition between both. So you end up spending time to make your interface, but it doesn't really solve the problem in the end. And adding to that, now that you made an interface, it's also becoming harder to use the advanced features from the packages. Because since you're trying to abstract a package, chances are you're not going to try and use the full scope of the package, because otherwise the interface is just a clone of the public API of the package, if that makes sense. So you end up limiting yourself on purpose, but then you avoid some cool benefits. Like, for example, you may end up breaking the lint rules from Riverpod, because nowadays, since everything is abstracted by your stuff, the linter doesn't work anymore, since that's no longer common code. That's just one possible thing. Overall, I would say try to. There is this paradigm called Yakni. You and gonna need it, and that's one of the pattern Flutter use. It's in our wiki. I would encourage looking it up. I would say that's about it for me. In conclusion, hopefully, I've convinced some of you that there are some downsides to doing stuff by hand. It's definitely not free. I guess.
Yeah, thanks a lot. Do you have any questions for Remi? Not a single question. I understand everything about state management.
Of course.
Yeah, give it up for Remi. And in 10 minutes here on main stage, we will have Anna that will talk about the annotation in Dart. And downstairs on the studio stage, we will have Ingvild that will talk about how to use the multi-child render object widget. So see you in 10 minutes. All right, let's get started. Now we are going to talk about Dart annotations in depth. Behind the by Anna. And if you don't know Anna is the one always bringing chocolate to conferences. That's the only thing you need to know about her. Please go ahead, Anna.
All right, so if you spend some time doing Flutter development before, chances are you've seen a warning like this. Here we have a widget with a build method, and it produces a warning because it's missing the override annotation. And how many of you have ignored a warning like this after upgrading Flutter in your project? Over time, some APIs get outdated, and they are marked with the deprecated annotation to make us stop using them. So we are interacting with annotations like override and deprecated quite a lot in our daily Flutter development. They trigger analyzer warnings and are used by library and framework authors to communicate the correct ways of using their API. And our bare responsibility as Flutter developers is to comply with those guidelines. However, it will make us even better developers if we learn to apply these techniques in our own code. It doesn't matter how big your project is or how big is the team working on it. If you're going to maintain it for some substantial amount of time, even if you are a single developer, annotations can be a great way to provide technical documentation for the code right inside the code base and communicate the intention of how it was supposed to be used. Of course, documentation can be written somewhere outside of the code base. It can list all the best practices, naming conventions, architectural principles of the project. But it's most efficient when it is built into the code, issuing analyzer warnings the moment something is off. That's way better than relying on CI checks that run after the code is written or waiting for someone to call it out during the PR review if it gets caught at all. So today I'd like to talk all about annotations. Before we continue, I do something more than just bring chocolate to Lucas. I'm Anna, Dart and Flutter GD from Ukraine. I'm passionate about technical excellence and quality and about sharing my experience online. So I'm currently leading the client platform team in a UK fintech company called Tide, where we develop financial platform and associated services for small and medium businesses across the world. And we write our mobile applications with Flutter. So let's start by reviewing what built-in annotations are available out of the box, which you can leverage in your code base. I'll start with the most basic one, override. Here we have a classic object-oriented example with an animal abstract class and a method called makeSound. And we have a child class cat that provides an implementation of the makeSound method. This code generates a warning because the member makeSound overrides an inherited member which isn't annotated with override. And this will be true for any case where a child declares the same member as the base class with the same name, but does not use an override annotation. This is done so that developers either explicitly say they want to replace the behavior of the superclass with the annotation, or they choose a different name and not confuse the users of this class. And this makes the code base more error-prone. We use deprecated much less often in our own code bases, but mostly face the consequences of it being applied in libraries or frameworks we use. Authors use it to indicate that some API are getting deprecated and will be removed in the future versions, so we should stop using them as soon as possible. And we can apply the same principles in our own code base. In this example, we have a dinosaur marked with a deprecated annotation with an explanation, extinct reptile, and the makeSound method is annotated with a plain deprecated annotation. So below, when we try to instantiate a dinosaur, we see warnings that this code is deprecated and shouldn't be used. Next, here we have a base class animal marked with immutable annotation. That means that every subclass of animal must have only final fields. But in our case, class rabbit has a mutable field name, and thus we get this warning. It is another nice way for library authors, or ourselves really, to enforce the intended usage of the class and prevent mutability bugs. Here we have a base class animal with a method eat. It is annotated with must call super, which means that any subclass overriding this method must still call the base implementation. But in our class hamster, we have overwritten it without calling super. And if you check the implementation of the base class, you'll notice that it updates the internal object state, and without calling it, the hamster class implementation is buggy. So it's nice that animal class authors have a way to configure analyzer with must call super annotation to immediately warn us that we are violating some contract. Now imagine if our animals lived in some kind of environment or habitat. Here we have an abstract class called habitat with a list of animals, and a class called Earth that implements it, and we have a global final habitat instance. Now, we want animals list to be up to date with all the animals that gets created, but we don't want to pass habitat instance around all the time. So animals access it via that global variable and register themselves in the list. This code, as it is now, is hard to test. We all know that Earth is somewhat unpredictable environment, and in tests we'd like to replace it with something we can control. In real-world projects, a good example of such an environment would be a file system. But if we made this global variable non-final, it will open the floor for potential bugs. So what we can do instead is to transform it into a getter that would either return a given instance or instantiate the Earth class as a fallback. And we can mark this given instance with visible for testing annotation, so it can only be provided in tests. If accidentally some production code tries to override that habitat instance, it will produce analyzer warnings. Next, I prepared a few lesser-known annotations just to tickle your curiosity. UseResult can be used above methods, getters, or functions to force you to use the result of it returns. In this example, we have a class called chicken, and we have a destructive method called collectEggs that clears the list before returning. So it would be a real pity to lose all those eggs if the result of this method is not stored. So since I applied the UseResult annotation above collectEggs method, the code below produces a warning that the value should be stored. And there is an annotation called do-not-store, which has the opposite effect. Imagine there is a getter which is likely to return a different value every time it is called, just because the environment it talks to changes quickly and is very dynamic. Like, for example, animals' population size. So we wouldn't want someone to persist this number into a variable and make decisions based on that local copy, just because it immediately gets outdated. So by annotating this getter with do not store annotation, I can produce a warning when someone saves its value. It's quite a rare case, but still nice to know. And this list is not exhaustive, and you can even find more annotations available in meta package. It even still contains the required annotations that we used to apply on named parameters before it became a language keyword. Now, as someone who works with in a team with over 100 of Flutter developers on a project with millions lines of code, where it is impossible to track all the changes and review every PR, I always look for ways to automate code quality guards and minimize human errors. In a project of such a scale, there always are some custom agreements that cannot always be fully covered with just built-in annotations. However, you can create your own custom annotations, and First, let's explore what annotations really are. Override is just a constant instance of some empty private class. And thus, it offers a single usage, just using this constant instance. Deprecated is also a constant class with a single message field. Here we have deprecated with capital letter, which is a class name, and thus a constructor name, and deprecated with a small letter, which is an instance of this class. This here is also a good example of naming convention for annotations. Class name with capital letter, instance name with small letter. Really just a regular Dart code. So this instance can be used directly, just as the override annotation above the make sound method, or we can create different instances using the const constructor, providing a custom message, just as we have above the dinosaur class. The main point is to have a const class constructor and its instances as const, and that's it. Annotation is just a constant. So let's now create our custom annotation and see how it can serve as code documentation. As an example today, I will be demonstrating an annotation called must use const. Let me explain. In sizable projects, we may be relying on tree shaking to exclude some undesired code from the bundle. In this example, dev utils are only initialized for development builds, and we rely on tree shaking to exclude them from production builds. The tree shaking mechanism relies on constant values to decide about the dead code. And it is relatively easy to satisfy such a requirement at first when you're just developing the functionality and the condition is straightforward. But over time, conditions may stack up, the code gets moved around, refactored in a hurry, and actually before you know it, const get replaced with final because of some dynamic condition. And without any warning, development utils leak to production build, and nobody notices the problem until a few releases later. Actually, this is a very real issue that happened in our Flutter project. And this is where must use const annotation would come in handy. Let's start with its declaration. Here we have a Dart class called must use const with a const constructor and const instance of such a class. Also notice a target annotation above this class. It indicates what type of code elements can be annotated. In our case, it's a top-level variable. So it will automatically produce a warning if something unexpected is annotated instead. And here is an example of how it can be applied. At the very minimum, it reminds developers who come to maintain or refactor this code about the previous agreements, and hopefully it makes them pause and think about the reasons why this annotation is here. However, it would be even cooler if somehow we could automatically make sure that the top-level variable it annotates remains const. Developers still may forget about the requirements or get inattentive, but analyzer will not. And having a warning like this, it would definitely have helped us avoid the production issue in our code base back then. Well, in fact, in many cases, annotations have corresponding linter rules. Even override will not give you a warning without annotate overrides rule enabled. So now I'm going to show one of the ways to have custom code checks. I chose the path of building a custom analyzer plugin because it has the benefit of integrating your custom rules into the standard framework reporting mechanism, which means you get warnings right in your IDE the moment you introduce a problem, and also through the standard Dart analyze command. Here I prepared a very simplified, maybe not the most efficient example of how such a rule could be implemented with custom lint package, just to give you an idea. Here we declare a child of Dart lint rule and describe a warning it will issue. This top-level variable must use const. Then we subscribe to a callback that will be triggered every time the source code we are analyzing contains an annotated element. And inside the handler, we check if the annotated element is a top-level variable. And if it is annotated with must-use const annotation. But if it is not const, we issue a warning through the reporter. Although I made this example look very simple, the combination of annotations and custom linter rules is a rather advanced topic, but it can bring great benefits when working on the larger code bases, as it provides automated enforcement of best practices and following team-wide agreements, which is sustainable over time. If you're interested in more details about creating custom linter rules, I can recommend to check out this video. The API has changed since the time of recording, and most probably it will change again very soon. So be sure to also check the latest documentation for that. And I would also like to point out the role of annotations in code generation. We all are probably used to using JSON serializable package to help us with JSON deserialization of API responses, and are used to writing a code like this. Here we have a JSON serializable annotation. It is a critical part of the implementation without which the code will not be generated, but also it is a part of code documentation, thanks to which we can understand what code will be generated without actually reading through it. And now if we look inside the implementation, once again we see a plain Dart class with a const constructor and a few final fields. This time they configure the output of the code generator will produce. And the class is annotated with target kind class type, so this annotation can only be applied to classes. Two conclusions from this. First of all, once certain agreements in the project are established around how we do JSON deserialization, we tend to repeat the configuration over and over again. But remembering that annotations are just regular Dart classes that can be instantiated, we can create reusable instances of such annotations and apply them instead of copy-pasting the declaration and achieve exactly the same result. And second conclusion is that we can create custom annotations that will drive custom code generation. Well, actually, in this context, all annotations, including JSON serializable, freezed, injectable, route page, REST API, all of them are custom. So for this example, I'll demonstrate an annotation from my barrel files generator package. Without going into much details about the package and motivation behind it, there is an annotation called include in barrel file. It can be applied to all top-level elements like classes, enums, global variables, functions, extensions, so on. And after code generation with build runner is executed, those elements get collected in a single barrel file for the package. To achieve that, first I have declared an annotation class and an instance of it. And this once again is the simplified version of the code that collects all code elements annotated with this particular annotation. Then it gets the names of those elements and the name of the Dart library they are declared in, and combines them into a single export directive. And this is the method that produces the output code. This example is not full from the standpoint of creating a code generating package, but I hope it gives you the idea of how generators can rely on annotations and Analyzer API to parse your input Dart code and produce the generated output. If you'd like to learn more about creating a code generating package, check out this recording. And to sum up, today we have discussed what annotations are, how to create your own custom annotations, how you can leverage them in your projects. We have seen how they can serve as code documentation, help produce analyzer warnings with custom linter rules, and help configure code generators. And my hope is that after this session, you'll start looking at annotations not only just as something you have to use in your code base occasionally, but a tool that you actively leverage to make your code base more expressive, more maintainable, and reliable. And that's it for today. I'll be around after the talk, so don't hesitate to ask your questions. Thank you.
Thank you, Anna. That was great. Yeah, if anyone has any question now, we have 1 minute. Any questions? Oh, one in the back. I'll repeat the question in here for the stream. So, can you talk about the limitations of a custom linter? Like, what can you do in there and what can't you?
Well, you can do a lot of stuff, like read the source code, read all of its properties, make conclusions of whether it satisfies your rule or not. However, I must admit that my development experience with this package wasn't great because it would quite often not connect, crash, or being slow. And custom lint is still, I believe, currently the most convenient way to develop the analyzer rule. However, things will pretty soon change, and yeah, stay tuned on the news.
Yeah, and if you have more questions about the custom linter package, Remi that has written the package is here too.
Yeah.
Catch him in the break. Next up is Building Efficiency in 2025, Build Apps Faster with Flutter from Mateusz, and that will be on this stage. And downstairs we have Architecting for 15 million users by Morgan Hunt. And that is in 10 minutes, so see you soon. Great. I'm free. All right, let's get started. And this is a sponsored talk from Lean Code, which has, I think you've been here every year too. We've had Flutter and Friends. We're very happy to have all the Lean Code crew here this year again. And we have Mateusz that will talk about mastering efficiency in 2025. And if you don't know Mateusz, he's a pro Flutter developer, of course. But what you probably don't know is that he plays in a band and produces music. So you can chat to him about that on the party. Take it away, Mateusz.
Okay, thank you very much. All right, so let's wait for the slides. And yes, okay. Hello, everyone. Welcome to the talk about mastering efficiency in 2025. And you're gonna see, if you read the abstract, it's gonna be a completely different talk, but I didn't change the abstract, so a little bit of surprise. And I'm gonna talk about why. But for now, who am I? I'm Mateusz. I'm a head of mobile at Lean Code. We're a software studio from Poland that's very, I think, popular in Flutter community. I'm also a Flutter and Dart Google developer expert, and I've been doing mobile for over 10 years right now. And I started with Xamarin. So if you want to talk about suffering after the talk, and you also did Xamarin, feel free to hit me up. Okay, so about Lean Code, maybe you know us. If you don't know us, we are a software studio that is very much specialized in Flutter, and we are doing enterprise projects and scale-ups. And we did a couple of banks, explicitly 3 banks, and also some European manufacturing, some enterprise companies. And we specialize in doing Flutter at scale in large teams like 20, 50 people or things like that. We also provide some guidance, audits, consulting, and everything. Okay, but let's go to the point. So this talk was meant to be different because I already gave a similar talk this year, but the word efficiency is kind of a tricky one, and it's kind of a tricky one because what actually efficiency means. So why do I want to talk about efficiency? Maybe if you're working with Flutter for some clients, for example, especially if you're a freelancer or a software studio, probably in the last month or last year, a lot of clients asked about efficiency, or were using the word efficient, declined in many forms as talking about doing things cheaper, usually, or doing more in the same amount of time. And of course, everyone that does multiple projects has some strategies and tactics for doing things faster, right? This is normal stuff, especially for us programmers. This is like, first thing we think is how to automate this, or how to make it, like the next time, make it much quicker for me. But of course, this year changed this meaning, because many times when I talk to clients about efficiency and what they meant by efficiency, usually it's equaled, do you use AI, or how you use AI, or is AI involved, are you AI oriented, are you AI driven, or any other form of that. And you can love it or hate it, especially AI. And I know that a lot of programmers love AI, and a lot of programmers hate AI, like AI hype especially. I know that there are some of you that are gonna think about, okay, cool, let's talk about AI, and another wants to leave when they heard AI, right? But you cannot ignore it. We just have to embrace it, somehow accept it, and think about how we can live with it. And I think it's going to be the talk for you. Either you love AI or hate AI. No place for, being in the middle, only being radical. So we're going to talk about what's efficiency, what was considered efficient before AI and how we dealt with that, and how AI relates to that. Maybe it does, maybe it doesn't. And does all this stuff gets deprecated that we learned for years and decades and wanted to craft our code? We also did some experiments in our company, and I'd like to talk about these experiments and how they succeeded or failed. So efficiency. Let's go to the definition. Of course, there's a physics one, which is a ratio of useful work performed by a machine to the total energy expended. So work divided by energy. In our development world, it's usually featured by dev time. So how many features can we develop for X amount of money? This is the definition of efficiency that our manager understands probably, and client most definitely. Okay, so we want to be efficient. Someone asks us if we are efficient. Okay, so what's considered as efficient? So usually not writing things from scratch, right? So first thing that client's gonna ask you is, okay, so you are going to develop login and signing up from scratch. I thought you'd already done that like 50 times. You're telling me that you've done 50 projects with authentication, and now you're gonna tell me you're gonna do it in 2 weeks because you have to do it from scratch. So this is the first thing, reusing stuff. Another thing that's unfortunately not thought through so much, because you don't have to think about it when you're selling stuff, is do you have to rewrite it in a year, for example? So how good, how structured, how maintainable our code base can be so that in a year it's still viable and you don't have to rewrite it. Then about UI, how to be consistent by design, right? So how to be consistent from the day one, and how to not have a random widget in some place. And then when we have all of it, then we think how to automate that. When we have all the best practices, then we think how to automate that. Okay, so let's start with don't write it from scratch. Don't write it from scratch can be, of course, understood on a different level. Different levels, for example, you can have an app template. Usually when you are a software house, software studio, first thing that clients gonna ask is, do you have any template project, starting project? And probably you have some starting project, because you don't want to Flutter create every time, right? Probably you have the same statement engine, the same libraries, the same dev dependencies, testing libraries, all that stuff, and probably some scaffolding code that you already have up from the start, some application.dart, stuff like that. So next you have some modules. So it's maybe not simple features, but usually, for example, you have authentication. You do the authentication usually in this manner. And for example, we use Kratos, which is one of the open source authentication stacks. It's written in Go. And this module is not only about mobile or Flutter. It's really cross-cutting domains. It's technology. So it's your backend if you need it. It's your mobile. It's all the stuff related to that. But it's not things like couple functions. Usually, for example, if you have a notification center in the app, it's usually not only about having your push notifications set up. It's usually about being able to send a notification to some user, being able to have some inbox, being able to mark things as read, being able to navigate to some other part of the app, localize them. Probably they also want to send emails or SMS, and so on and so on. So you're gonna have some modules, right? If you want to reuse them. Okay. So we have some app template from the start. We have some modules that we share. then we want to write some code that's maintainable, right? So what means to have a maintainable code base? After our Crédit Agricole adventure, journey, maybe it's a better word, which lasts, I think, more than 4 years right now. So we have a pretty large code base. I think it's over 1.5 million lines of code, and a lot of features, a lot of separate teams, feature teams. And we can see after these 4 years that we don't have to rewrite it, which is pretty good sign, I have to tell. Like, you know, after 4 years of having a large-scale app, you don't have to rewrite it. It's pretty nice. So how to do that? What should you do that? Like, how should you do that? Usually, it's all about having well-defined standards. Maybe not even about one standard being better than other, rather than really keeping one standard and well-define it and really enforce it over others and all the people in your development squad. So, for example, this year we composed finally all the documents into one huge document, which is our Flutter architecture standards, like, you know, some things that we are all in Leushchenko. We have 35 Flutter developers, and we want to agree on something. Like, for example, let's agree on using I don't know, block in this way, or creating it in this way, just to, you know, just to all agree on that and all use that. It's not like the best way, it's not the worst way, it's just a way we think it's usually a good way. And it's, as you can see, it has a 40-minute read, so it's too long didn't read, kind of stuff. So what's important is to just answer some questions. If someone is gonna ask you, if a new developer or anyone, do we use block? Yes. How do we use block? This and that. Do we use hooks? Do we forbid hooks? Or do we use provider or not? Do we forbid that or not? Do we use get it and so on? Do we cache data? Maybe not, maybe yes. Which data by default we cache? And so on. And also, we are okay with explicitly not using our own packages. For example, we have also, Remi talked about Flutter hooks. We have a Leushchenko hooks package, which is implementing some of the common additional hooks that you might use. It's open source. And for example, we have use block hook there, which we maintain as an open source stuff. But in our standards, we don't use it, because we thought, okay, if we're gonna use block provider and use block, which are two different ways of initializing blocks, we don't want two different ways in our repository. People usually like provider. We notice that they are like more comfortable with that, so let's not use the other way. Maybe we still maintain it, maybe someone in the community prefers using hooks all the way, but let's just not use it in our project. Okay, then we want to be consistent by design, meaning we want to have some design system, right? But design system is a huge investment. You know this guy, probably, Lucas from Widgetbook, and he probably wants the whole world to have a design system, right? And he's gonna ask you, why not having a design system in your project? Or he's gonna tell you, get yourself a design system. But then many clients tell you, you know what, we just want to deliver it. We don't really need a design system. So how to solve that very uncomfortable situation? Because from one perspective, you want to have some design system because it's much more maintainable, much more also efficient in the future to create new features and new pages and keep that all that consistent. On the other hand, it's expensive. But you don't always have to have a new design system. You can start with some material design Figma. There are Figmas out there that are already a design system ready to use. For example, we have a Leushchenko design system blueprint, which is kind of a template design system, and we offer our clients, if they want to start, they can fork it, so they copy the Figma, and we start the project with also forking the code of the design system, and it's their design system. And maybe they won't do anything but changing the colors. Maybe they add some components, it's up to them, but at least they have well-structured design system, they have all the states, they have all the things like, typography, colors, tokens, Figma variables, Figma components, Figma component properties. So It doesn't matter like how it looks like, because the UI can be whole different in each of the apps, but the structure is there. And usually the thing that people forget about when you work with someone on Figma is the structure. Like they like, you know, designing things, and they are pretty shiny, nice, and functional, but they are just not ready to be used in the way that developers love using Figma. Of course, on the other hand, you can have a dedicated design system for your brand if you are in some product team that is very, you know, that has the branding and a lot of money. For example, we did that for the banks, the Crédit Agricole, when we implemented atomic design pattern. So we had atoms, molecules, and organisms. Then you can be creative, and you can do much more in terms of the DS. But also, it's a good practice to look at Figma and define your objections, because many times when you start a project, if you do a nice Figma audit from the start, so maybe you are this developer that loves having organized Figma, or you can hire us, or you can ask the best friend that is the best UI developer in Flutter, and they can just have a look at the first day, talk with designers, because if they are gonna, you know, if you're gonna make it better from day one in terms of the structure, it's gonna save you a lot of time and money, and you're gonna be much more efficient in terms of delivering features. And you're gonna see also why in a minute when we go further with that. Also, it's a perfect time for building a design system in Flutter, really. Like, these are the times that are much better than it were, because of the whole decoupling situation that is happening right now. So before, as you know, you had Material and Cupertino as part of Flutter SDK, and finally, after many years of issues comments, discussions, and stuff like that, the Flutter team decided to move Material and Cupertino design libraries out of the core SDK into standalone packages. Developers will gain more control over their design system versions and stronger unopinionated core framework for building custom UIs. So this is very, very good news for all the UI developers in Flutter ecosystem. And as I said, it's a perfect time for building a DS. If you want to know more about building a design system in large Flutter app, I recommend you this free article on our blog by Albert that has done a talk today already. Yes. So the last part of efficient stuff I mentioned is to automate it, because we already mentioned, you know, you have some architecture, some structure, well-defined rules, but it was a Confluence document. Who makes Confluence documents, right? And we had Figma, we had design system, and how to automate it. So how to automate it means usually using any tooling that we can, and in Dart, we can use a static analysis, which is Dart Analyzer. And with Dart Analyzer, you can also use custom lints, which is the plugin and separate package. So we love Dart Analyzer. We have our own open source opinionated set. It's very opinionated, it's very strict, but I really recommend you, even if you're not gonna use it, I recommend you to look at it and just see if you are agreeing with, like, if you agree with that. This is very, very nice, I think, exercise for you, just to see other companies' lint set and think about if you agree or not, because it's a nice, I think, it's a nice argument in your head. Of course, you can file an issue as well, but it's opinion, right? But still, we can discuss about it. And it's not only a set of links from Flutter, it's also custom links like there are written by our developers. So for example, you can have things like adding a suffix to your qubit names so that it's, well, you know, as we mentioned, we want things that are well defined and well structured. You don't want to forget about having a qubit suffix, for example. Or if you return sliver, you want to have a sliver prefix, right? so that everyone knows that it's returning sliver. The worst thing is when you have a widget, you think it's a widget and it returns the widget, but it doesn't return a widget because it's a sliver. So let's have that in the name. And my favorite one is use design system item. It's also open source and available in our link code lint package. And this is a great rule to enforce using your own design system. Even if you don't use, fully blown design system on Figma or anything, but you just have your set of components in your app, and you know that, for example, you have your own app text or app button, and you don't want anyone to use material button or material text. This is a classic situation. When you have everything, you already have your set of components. Someone did a huge amount of work of getting it accessible, tested, widget tested, golden tested, and then a new developer comes, for example, and they just use a material text, and everything's over. So here you can just define a rule, like for example here, use LNCD text instead of text from package Flutter or instead of rich text, and so on, and you can have multiple of them. And then you will have a problem in VS Code, for example, or other IDE. Text is forbidden within this design system, and then you also can make it the way that you want compile on your CI, so that nobody can merge the code with it. And what is also a very, very new thing is that the new Dart Analyzer plugin system is gonna come, and it's gonna introduce the way that you can integrate your custom lints directly into Dart Analyzer. So we can rewrite them to Flutter Analyze, and when you run Flutter Analyze, your custom lints will be run as well. And it's very important because it's gonna be just much easier, and custom lint doesn't have to be workaround anymore. And we also have an article about it because we rewrote on the developer version, like dev version of the package on pub. You can see we already tried to rewrite all our custom lints to the new Dart Analyzer plugin system, and we wait for it to be stable. Okay, so now AI comes, right? And we were efficient with all that stuff. And someone comes to you and they can say, okay, but AI makes all this stuff deprecated, right? Because I don't care about it right now. I can use cursor. Let's vibe code it. I don't have to think about it. It's just I can vibe code the whole app and so on. And this is a very important question we have to answer today. Does AI make all this stuff deprecated? So what's AI? Usually for people in terms of coding, we have this spectrum from chat to build a 3D game in World War II times and FPS and all that stuff. And we have cursor. So ChatGPT is great when your uncle is asking about how to get rid of the bad smell from the sink. And this is the level of abstraction which is great also for asking, how to use sliver in that and that situation. On the other hand, we have, on the other side of the spectrum, we have lovable, which is your manager telling you that you're lazy, and he vibe coded all your work in 5 minutes last night. This is the classic situation when someone comes and says, you're gonna be obsolete, bro, because I vibe coded the whole application yesterday. And in the middle of that spectrum is some agentic IDE. It can be Cursor, Windsurf, I don't know, Claude Code, Gemini CLI. So something that can write code with you on your rules. And we're gonna talk about Cursor, like agentic stuff like Cursor or Claude Code or anything that you use. So typically when I talk to people about their experience, recent experience with Cursor, it's like this. Like, so you try to do something, it kind of does it, but it kind of not. then you have to kind of fix it, and it kind of doesn't fix it because it kind of introduces another error, and so on. So it kind of works. And I did a small experiment before this talk. So I asked Gemini for generate me 2 code bases for the same app. One was to generate the worst code. Like I asked the Gemini, like, let's have the worst code possible. And another one, I told it, like, imagine that you are like top-notch craftsman, software craftsmanship. Like, imagine it's the most important piece of art in your life. So, and I gave the same, and then I gave the same prompt in Cursor. No rules involved, just the prompt. The same model as well. So first I had all the app in one file, main.dart, of course, because Gemini did what I told it to do. So it's everything in one app. It has global variables, set state for everything, mixed double quote strings with single quote strings, everything that's bad. And I prompted just create navigation to the new to-do list page. And it added everything in the same file. It added to-do list in the same file with the state, all the set state, all the global variables, and all that stuff. And then I had the same situation in good code base, meaning that it's having some file structure. So Gemini proposed some structure of screens, services, view models, widgets, and also it extracted some widget on purpose. And I had the same prompt, create navigation to the new to-do list page. And as you can see, it planned doing another screen. So it did another screen, did another service, another view model, and also then it extracted a large piece of code from the widget to another file. So it's also considered that. Okay, and then I thought, okay, we had the same prompt, no rules. The only thing that was different was the code base, right? So it got me thinking, what does it tell us? Like, what does it tell us in terms of experiment? It tells us that it depends on our code base, right? So the behavior of Cursor or any other Cloud Code stuff, it depends on our code base very much because we just seen that we had the same prompt with the same rules. So let's see where it takes us, what we can do. And let's answer the question, because the most important question right now would be, what makes our code base AI friendly? So what makes our code base, what makes this agent to generate better code, or maybe not better code, but the code you would want to have? Because this is the most, I think, the thing that we all hate the most about generating code is that it's not the thing that we want it to be. So I took the Flutter Tech Summit up. It's a closed tech executive event that we organized a couple months ago. And it was all Cursor coded, I would say, because it was an experiment. We didn't need the app for the event at all, because you don't need an app for an event of 50 people that is happening throughout one day. You don't need the app for that. We just created the app to try, vibe code it and see how much we can do it the Lean Code way, like the Lean Code developer would do the same or not, or how it ends up. So to do that, this is the app with the agenda of talks, simple map and notifications, something like that. And I found the Figma, and on Figma there are some additional features that are not there yet. And it was, for example, the survey. So, okay, as you can see, it's a multi-step survey, and in the end, you have to save some survey state. So let's get back to our efficiency stuff. Like, what was old school efficient? Old school efficient was to have well-defined architecture. So in our like Lean Code app, we also have well-defined architecture, and everything's written down. And when I started prompting Cursor, first thing it created was the plan, right? And the plan depends on your architecture. This is the first thing that you're gonna notice when you change the architecture. It's gonna change your AI plan. So if you want, it's really impactful. As you can see, it creates feature directory structure. And it's just because we use feature-based architecture. Normally, it wouldn't do that. So if you use feature-based architecture and you tell it that you use feature-based architecture, the context, which is the entire code base, is using feature-based architecture, there's a huge chance, very huge chance that it's going to use feature-based architecture even if you don't tell them. Another thing, create survey qubit, like the same thing. It knows that we use qubits. Also, it starts with data models, then it uses qubits, then it creates UI. This is exact flow that we wanted it to do because we have defined that in the document. Another thing is adding navigation routes. You know, you could normally cursor, what would cursor do in the random code base? Just run navigator push and some random path or random route that is dynamic, right? And if you're having your convention throughout the code base and in rules, it's now adding navigation routes. Another thing is analytics IDs. In all buttons, we use analytics IDs just you know, so that we enforce it so it's easier to track analytics, because normally no one remembers about tracking things in analytics. You release the app to production and you have no analytics events. So we thought, okay, let's make it, you know, enforce that every button has to have analytics IDs and they are in one file. And it's also here, right? Because cursor doesn't know what analytics IDs are, but it can see that we use it everywhere. They are enforced by some lints, and so on and so on. So it all works together. Yeah, and here we have also like analytics ID, page IDs. All button interaction have analytics IDs. This is something that's not a common thing in Flutter. So it's not like it has to learn that from some model. No, you can really like put a lot of context to it. And it created like the survey feature directory with models, widgets, qubit, and a page, exactly like we wanted it to do. Another thing, linting. We were talking about custom lints and static analysis, not only custom lints, but static analysis in general. This is a very powerful tool with AI-assisted coding because it provides automatic feedback. Like when you see how the agent works, every time it adds some code, it runs some Flutter analyze or Dart analyze, or if you are in other technology, some equivalent of that. And it checks if there are errors. And this is a very powerful entry point for you, because it's gonna check for the errors, and if you can implement your own errors, then it's gonna check for your errors. And this is very important. Like, as you can see in here, design system violations. Normally, it wouldn't tell you that because it has no how to say that, like no exception that tells it so. But since we implemented our own lints and it can see in the IDE that it's a problem and it can compile, then it reads the description and it can see that there's a use design system item description. The same thing is with exception parameter naming. It's also a custom lint. So you don't have to tell them to do so. This is important because it can go in this loop and it's always seeing, okay, there are some other stuff that are problems, but you don't have to define them on the go. You can define it statically. It's very, very powerful. And here you can see that our custom lints are found as errors. So it's very important because then cursor is gonna go all the way until it fixes it, because it knows that this is the error. Another thing, design system. We talked about design system. I took from this Flutter Tech Summit app, I took this tab bar. It's not implemented there because we had one day, but we wanted a multi-day agenda just to check how it's vibe coded. But in the production app, there was one day, so we didn't implement that. So now I wanted to do that. I tried yesterday, of course, to be prepared for the presentation. And I took this component, and as you can see, it's purple, so it means it's a component in Figma. So I noticed that we don't have it implemented in our app yet. So I told the cursor, okay, let's implement a selected Figma component. Its selected Figma component means that we have a Figma MCP. For those who don't use MCPs, you can have this connection to your Figma, and if you have selected something in Figma, it can ask the Figma about the image and the code, like properties, tokens, variables, and all the things that are in Figma. directly to your cursor or any other tooling that supports MCPs. So I'll help you implement selected Figma component and add it to your app design system, right? And the to-do list is very important because explore the existing app design system structure. This is very important. Create a tab bar with fill and hug variants. So as you can see, those are two variants. And it's very important because if there are variants, it also knows its variants. So it's going to implement the Flutter widget like it would have variants. So you have, for example, two constructors. So it's the way you want it to look like. And then implement tab bar item with states. The states are taken from the properties. So another thing that's very, deterministic, that you can steer it. Add required colors to design system theme, and add tab bar to widget book, another widget book mention. And I even specifically didn't tell it to use widget book. I didn't tell anything about widget book. We just have widget book out of the box with our design system. It noticed that all the design system things have the widget book equivalent, so automatically it wanted to do so. And then it did that. I ran the widget book, and it looked pretty much the same. The behavior was the same. And what's important, the properties and the variants were the same. So when I use it from right now, and it's gonna be used the same as in Figma. So then when I'm gonna implement the whole feature, it's gonna be also used the same way in terms of the properties and functionality. Okay, so what it means, the AI-friendly design system, what's making it AI-friendly? Actually, this is the same slide I had about dev-friendly stuff. So it's the same thing that are friendly for new developers, junior developers, or all the developers. When you want to organize things, it's the same thing that's AI-friendly. You can see app text field has decoration that's very strictly typed with this API only for this app text field decoration. Here we have app list item and app icon only with app colors allowed. Then we have only predefined sizes, and the semantic label is required. This way, it won't compile without it. And the only way cursor can generate code is your way. This is very important. You just make your way the only way, pretty much. And now this design system item makes even more sense. So when someone's gonna tell you AI is gonna deprecate your craftsmanship, it's not. It's gonna enhance your craftsmanship, literally, because it can use your craftsmanship. So yeah, we should do good code still, right? And here, implement support for multi-day agenda. We already had the design system widget. Implement the selected component using the widget you already did. And it's called design system widgets, which is our own small MCP that we have at Keynote, which is telling the cursor what design system components we already have in code. So it's app tab bar, and as you can see, perfect. I can see that already there is an app tab bar. I'm gonna use it, right? So when we add all these things up, we have architecture, links, design system, and we just add, AI readiness to that because of the rule, because of the way it works. Remember that, for example, this use design system item, it's in English, right? And it's very important. When you have descriptions in your links, when you have examples in your links, this is this exact pattern that LLM wants it to have. And when you add all this stuff together, you just end up with the feature that actually works. It's the same like Figma. It uses a design system item. It has a widget book use case. Even if you didn't think about widget book use case, it's just out of the box there. So it's maybe even better than you would do in the first, I would say, first run. And it's very, very interesting. So this is only like the tip of the iceberg I showed, because it's only the mobile part. But if you want to learn more, my friend, which is the head of backend, is going to host a free webinar about it, because he's mostly the guy that's leading the experiment. He is the guy that's leading the experiment in our company, all the parts, mobile, frontend, and backend. And he's going to talk about the pitfalls, common caveats, things that we just noticed on the way. So last thing is about the ugly part, because one day a fellow developer came to us and said he's against AI because he's seen PRs that are created by our developers for thousands of lines of code in one commit with 40 files changed, and you know everything the way that it was, not like before AI, like before all the craftsmanship articles, all the architecture presentations they watched. You know what I mean? Like people forget about their craftsmanship, and this is very important. You have to remember that, because it's not about forbidding AI or enforcing AI. It's about that some people with new fancy shiny things, they forget about all the stuff that they already did. And it's not AI, right? It's you. This is very important. It's just the tool, and you used it in a way that it sucks, pretty much. You are still the code owner. This is something very important you have to tell in your team. If you're gonna let them use AI, you have to tell them you are still the one to blame. This is your code. And if someone says, don't worry, it was AI generated, this is the same like 10 years ago, someone would approach you and they would say, it was copied from Stack Overflow. And now we know that if someone tells you that, it's a big no-no, right? It's not a normal situation when they just commit something without thinking. And this is the same with AI, just a different timeline, because we are 10 years later. So it's not that AI code sucks, like if something bad happens. It's about your code sucks, right? So yeah, that was pretty much that. But this is a sponsored talk, and I'm gonna use that. So spare me a minute, or rather spare me one last slide about how we can help you. Because all the things that I told you about, all the craftsmanship, all the architecture, all the Figma audit stuff, this is exactly things that we do with other companies, with our clients. We help with migrating to Flutter. We help with architecture. We also help with like AI readiness, in terms of what means AI readiness, in terms of like exact things I told you about, like if it's well defined, if the rules are there, maybe there's some links that you can have, maybe the design system and so on, widget book, automating stuff with Patrol. We are now experimenting with using AI and Patrol, and it kind of works, I think. So you're gonna see some new things in Patrol soon. And finally, like AI-assisted development with Flutter, because it's all about taking all the stuff we already knew and getting it to the next level, I think. And yeah, thank you. Do you have any questions? Yeah, I can see Dario. Yeah, this is a great
I'll repeat the question for the stream first, because they can't hear it.
Yes.
So if you have an AI-friendly code base, do you still add context to the question? Was that the question?
Yes, yes. Yes, it's a great question. In this webinar, the guy is going to tell you that we explicitly attach the rules. For example, this is kind of context we always attach, because the intelligent rule applying is very bad from what we saw. And everyone I'm asking about it, they say that it doesn't work for them. So I think it can be just not working feature at all. And also we try to, if you know like this is the only file, like or like, then yes. But I don't do that usually. I try to think how to do that in a way that later I don't have to do that. So I try to not. But the rules are the ones that we explicitly add, yes. Because we try to divide into steps. Like right now, let's do the qubit. So you have the rule for that, like do this step. And we have the rule for this step. We don't want it to do too much or to go somewhere else. Just do one task for me. And manually forwarding them to another task, you know, so that you control it more. Yeah. Yeah,
Right,
about.
so I'll repeat the question for the
If you
stream.
want to, okay. I can repeat the question as well.
Okay, I thought it sounded like you were going to answer the question. So the question was whether you've tried to do a custom lean code MCP server.
Yes, yes, it's true. Like, yes, we did. It was the design system one, one here. The called design system widget. The design system widgets is our tool from our MCP, but it's very simple because creating MCP servers is very simple. So do that totally. I recommend everyone to do so because it's unfolding the magic and it's no more magic to anyone. So we do that to list all the widgets from the design system because it can, it can look for a design system folder. It can also not look for it. And this way, it's always looking for it. This is why. Okay, do we have any other? I can see someone in the upper rows. Yeah, let's just. Yeah, it's okay. Yes, you.
Okay, if you solved Code Connect for Flutter and whether it could be solved with Flutter.
I didn't see that. I didn't see that. I know that the Figma MCP server, when it gets the code, it just gets the HTML every time. But I think we do it. We prefer the other way. So the other way meaning, I want to know from Figma which component is it and the properties of that component. I don't want it to do anything else. Because if I match the exact component from my code, then you have a much bigger win, I think, because it's on your terms. Because you can tell it to use exactly your widget, and then exactly your widget with your exact properties and constructors and stuff like that. Because usually you want it to use your code. So yes, so I don't know this feature. But I would want it to do this type of matching, if it answers your question. Yeah, Simon.
So question is, they provide this Figma design template for the customers, and the question is whether the customers are actually sticking to it or if they're just doing their own thing.
Yeah, so sticking to components, you mean? This is very important, and we are gonna fight about it if they're not gonna stick to it. Usually, they are happy that they have a Figma already done. They just change the colors. Sometimes they want to change some minor things, but usually people are lazy, which is in this case very nice because you already have the design system and you don't have to fight about it. But sometimes they use stuff like, for example, they want to use the same button, but underneath you can still in Figma you can do underneath you can recolor stuff. You can do it, like it's physically possible, I would say technically possible. And there are things like, I had that case, I don't know, a week ago when the close button was white and there was no way in this project that it could be white because it was totally out of the whole color palette. And it was marked as a component, but someone took one layer and recolored it. So these things happen, but it's, actually, it would be nice to somehow forbid it, but I'm not a Figma magician, so I don't know. But yes, so this is the answer.
All right, I think that's all for the questions for now. Thank you a lot, Mateusz.
Thank you.
A very nice talk with a lot of good takeaways. Now we will have some fika, which is basically like coffee and snacks, but since I think the people already served it like an hour ago. But there might still be some left out there. So yeah, go out, talk to the sponsors, and talk to each other out at the exhibition area. And we will start again at 3:45.
Can we get
Can we get the slide back up here? Ah, there we go.
But you have to.
Oh yeah. Oh yes, of course.
Hello, hello, hello. This is me testing the sound of this microphone. Hello. Let's talk about shaders. Ah, it's over.
Time for the next session. And it is nobody less than Renan, who I have known for 7 years now or something. We're developing Flame together.
Oh, yeah.
And the newest, like, big addition to Flame is the post-processing API, where you can actually like start using shaders in a cool way.
That's my talk.
Oh. Yeah, that's true. I should let the pro tell you about this. Give it up for Renan.
Thank you. Thank you, everybody. Yeah, just keep presenting myself. That's me. That's my name. It's pronounced Renan because it's Portuguese. And yeah, I'm a software engineer. And I work with Flutter at Superlist and with open source stuff at Bluefire. Bluefire is this amount of weird people, included the one that was just here. That was the least weird one. Me, Luan, Jochum, that's somewhere, I cannot see, I don't know if he's here, and 2 other folks, Eric and Dev Cage, that they are not here today, unfortunately, but we have a big amount of the Bluefire team here. We maintain open source stuff. One of them, the biggest, I guess, thing that we maintain is Flame. And, well, let's, this talk is going to be really heavy on some subjects. So I really need to know my audience, right? So is there anyone here, don't be ashamed, we're not going to judge you, but is there anyone here that is not a Flutter developer? Like, you don't know how to put a hello world in the screen with Flutter? Cool. Oh, one? Oh, all right. I don't have to teach that, at least. OK. Who here never touched Flame? Like, OK. Good. Good. That's cool. So there are some subjects that we have to clarify before going deep on what's post-processing and what's possible to do with it. But yeah, let's talk a little bit more about Flame itself a little bit, and why is it really necessary. Do we need a package specifically for games, since you can make some games with Flutter widgets? But the fundamental difference is how we think how those UIs should behave. App UIs and game UIs, they behave differently, and that's a fundamental that impacts a lot of the development process. We write UIs to be reactive with widgets. And not only widgets, if you go to any declarative UI framework out there, it's all about reactivity, and it's always about not updating what's not necessary to be updated. Because UI updates on games, on apps, they happen because of reasons. Because of user gestures, because something came up from the network, or from a WebSocket, from a response. It's always reacting to things. But on games, the updates come from internal rules, because every game, it's a word on itself. So it has rules like physics, how animations should happen, sprite animations, things blinking in the screen. They're not necessarily reacting to things. So that's why on games, we are more active. That's why we don't use widgets on Flame. We created the own component system. I'm getting ahead of myself. We can go deep on that later. But one funny thing from the perspective of someone that's helping the guys that maintain Flame, is that there's always 2 types of people that approach Flame. Most of them are Flutter devs that are never developed games before, and they're trying to go to that route. And the others are game developers that don't know anything about Flame, but about Flutter, and they're trying to go on that route as well. So we have people that don't know game dev, but know Flutter, people that know game dev a lot, but don't know anything about Dart, anything like that. So it's pretty cool to see, but after some times, these people become, after some experience with Flame, they become this on one type of thing, and this is what's about people that just learn tools or gather whatever is necessary, learn concepts, to get things done. So basically, you want to make a game, and Flutter is there. why not? So this is about more like the tools that we have at hand. And let's study a little bit about one specific, which is post-processing. But along the talk, you're gonna see that post-processing is just one thing. And that combined with other things, you can have interesting results. All right. Preparing for this talk, I was just watching old talks from all different events. And YouTube recommended me one from this conference. It's okay. Is there anyone from Flutter Friends here? It's okay to mention other conferences. I want to mention a lot of them here. So this, I think, was the big conference around Flutter, the first one in 2020. I mean, do you remember the Flutter community in 2020? It was really cool. Flutter was already dying. People already saying Flutter was dying in 2020. But yeah, and I had the opportunity to talk there. It was also my first time giving a talk. Meet with this guy here, Luan, which is the creator of Flame. And this was the talk. And it was really interesting to see that that talk is still present because we cover a lot of that thing I just mentioned about the differences between apps and games. But one slide I wanted to mention is this one. Oh, that's the one. Whoa, you're so young. Yeah, so this was the slide at the time where you mentioned what Flame includes. And this is a very interesting aspect of Flame because it's modular. It's just a set of lots of things that help that auxiliate people to build games with Flutter. And this what the things looked like at that point. And I tried to put that, to update this and put on with the current things that Flame offers, but it didn't fit the slide. So I put some of them here. To your left, you can see that there are some APIs that are included on Flame. And to your right, you can see a column of packages that bridge Flame to everything that's outside and can also be helpful to developing games. And this is thanks to the efforts of lots of brilliant community members, and also from the Bluefire folks, especially Spidon, Eric, Luan. Amazing job y'all made during these years. And I had the opportunity to work on this thing. Basically, this is the last addition to the set of APIs on Flame, and it's called post-processing, the theme of this talk. I think this is the third time me showing this title on the screen. I'm sorry for that. Not going to do it again. But just a disclaimer before going deep, you don't actually need shaders to make pretty games. People have been shipping fantastic games with Flame for the past 5 years without shaders, and I think it's totally fine. It's just a different style. Post-processing is just a tool. You can choose to use it or not. But yeah, in the end of the day, yeah, you can take the advantage or not, and still can ship great things, regardless. All right. Another thing. This is not my first time talking about this in thesis. Shaders and Flame is such a great subject. There's so much to talk about it that I think it's time to refresh a little bit. 2 years ago, I gave a talk in Colombia, and was basically Flutter, Flame, and Fragment shaders. And for that, I created this demonstrator. It's basically a game demonstrator that follows a specific look and has some different effects. But at the time, we didn't have post-processing API. So I had to create the whole thing by hand. Lots of it is over-engineered a lot, I confess. But now that we ship it, the post-processing API, this game is in the examples website, examples.flameengine.org, -flameengine.org. Yes, it's there. You can see the code. Using the new post-processing API, it's a great resource to learn this. And I also explored for an hour and a half with Craig on Observable Flutter about the source code of this. So if you want to go deep on this demo specifically, it's easy to do so. But I thought, well, y'all paid tickets for this. I'm not going to reuse this example again after 2 years, so let's do something new. And also, this is not my last time talking about this. This is part of a series of 3 talks I'm giving about the subject. This one's 100% Flame. I'm going to talk about Flame, Flame, and Flame. On FlutterCon, it will be everything you see today, but in comparison with what's possible in the Flutter side of things with widgets. And in the last one, it will be in Flutter Netherlands. I'll focus more on Flutter, on the UI side of things. So if you're going to watch any of those talks, if you're going to any of these events and conferences, rest assured that I'm not going to repeat myself there. This talk is here and today only. Yeah. So enough of introductions. Let's talk about what's post-processing. So the concept is simple, right? It's just a way to process what's already processed, post-process. So basically, you have a component inside of Flame that was rendered, but before that, the result of that rendering reaches the user's screen, you may want to add things or remove things or customize how those pixels look before it's rendered in the user's screen. So it's kind of a middleman, and yeah, let's a whole tree of components render and then customize it. Yep, and it's also can also modify all of these pixels, or it can rasterize first and modify, or not rasterize at all and just add things on top or on the bottom. We're going to see all of this. But how this looks like in code. So this is a very basic boilerplate for a Flame game. So basically, we have game widget. This comes from Flame. Do we have lasers on this thing? No. Right, so I cannot point. But there on the main function, we have a basic run app, and there's a game widget. And this game widget is from Flame, and it's responsible to add a whole Flame word, a whole Flame domain inside of the widget tree. So basically, Flame is just another widget. It's a very complex and rich custom painter. And to the game widget, we can pass an instance of my game. A very creative name for this class. And on the onloads method, which is the first thing that the game will run after being on the widget tree, I'm going to add a player, which is this sprite component thing that's animating there. And it's right there in the middle of the word. That's pretty basic. So for you guys that never saw Flame, you guys, Flame. Yep, so this is a shader. Oh, I forgot to ask, did anyone touch any fragment shaders in their lives? Never touch? Anyone that never touched it? Okay, good. So I'm going to talk to you guys now, to you folks now. Well, this is a basic fragment shader. So this one, every fragment shader works like a function. And the output of that function is a vector for. A vector for is just a vector of 3. It's a group of 3 or 4 doubles. And each one represents a channel of color. So basically, the output of a fragment shader is a pixel, the color of a pixel. And the inputs, they're basically, the first one is the coordinate of the pixel that's being rendered, which here is the Flutter frag chord. This comes from Flutter. And the other ones are called uniforms. These uniforms are just values you can pass to the shaders that are running. And there are 2 types of them. The number ones, in this case, vector2 of size and pixel, how many pixels the result's going to have. And another type of uniform is a texture. So it's basically a rasterized image. All right, so what's happening here is basically, first of all, in the main function, we are normalizing the coordinate to 0 and 1. And then we are making a calculation to group those pixels. So the outputs will look pixelated and the U pixels uniform means that the output will have that many pixels of resolution. So basically, this is a pixelate shader. So how do we pixelate Ember on that game? Basically, we add a post-processing. We wrap that component with a post-processing component. So yes, you can have parents and child components just like the widget system. We have in the component system as well. And this component has to receive a post-process that looks like this. So post-process will extend that class that comes from the new modular on Flame, and that class you have to overwrite the method post-process is the most important one, but also has an onload. In the onload here, we are just loading the fragment shader. That's almost like we were loading an asset, and you're saving in the paint, and this paint will be used to draw the things in the canvas. So basically, in the post-process, the first thing I do there is to rasterize the subtree. So basically, I'm taking the subtree of that component, in this case, just the Ember, transforming, creating kind of a bitmap, like a rasterized version of it, and I'm using that as one of the uniforms in the shader. Also, I'm passing size, and I'm gonna say that for this shader, I want the output to be 4 pixels by 4 pixels, and it's gonna look, after all of this, it's gonna look, oh, I create this. I totally forgot. Never create those things in the last minute before the talk. Yeah, so it looks like this after the post-process, pixelated. So we render the sprite, pass to a post-process, and after that is in the screen. This is how basically it works, the input and output, but here we're just passing one post-process. The fun thing about the post-process API is that we can group them and can have a pipeline of multiple post-process and can apply one shader after the result of another shader. But please don't rasterize on every step, because that can be very expensive and you'll destroy the performance of your game. And FPS is everything for some games and for some gamers as well. All right, so this was a very simple example, but I believe that showing the capacity of some APIs, the best way to do that is to show by example what can be done. Some of crazy ideas. I don't know how much time I have, but let's go a little bit deep on it. I watched a movie and I was obsessed with it. It's called Greyhound. It's on the Apple TV. It's fantastic. I totally recommend. It's about World War II and ships and sea battles. It's super fantastic. So I was totally obsessed with the theme, and I think maybe this is a good excuse to make a game. Let's make a game about a ship, and I imagine that the dynamic of that game would be an isometric view. So here's just an example of what is isometric of a ship in the sea. And I probably want to rotate it around, so we're probably going to need some kind of perspective, 3D-ish kind of things. And yeah, so the first thing to do is to put the ship on the screen. And I was looking around and I found this. This is a 3D model from Sketchfab. It's free by attribution. So here I am attributing that I'm using this 3D model. I put on Blender. With Blender, I managed to export these sprites. So this is a sprite sheet. If you don't know that, sprite sheet, people that don't know that, sprite sheet. So basically, this is a way to represent, to create animations out of bitmaps. So basically, I have all the frames of the animation here, but I'm actually not animating. I'm just gonna interpolate in the progress of this animation as the user drags around in the screen. So we can see the ship from various perspectives. It's kind of isometric. It's not orthogonal camera, for the people that know that. Yeah, but I think that's time for me to switch to some code. Let's see how this looks like. Is that fine? Can you all see? That's cool. All right. So yeah, so this is my game. It's way more complex than the other one I showed because it has a lot going on. So basically here we have a gesture input I put on the game level, but you can put this in the components level as well. Yes, I'm basically syncing user gestures with the game stage. The game stage basically is where you're looking from where you're looking into the ship. The ship component, it's pretty simple. It has this parent component here that's pretty useless for now. But the child component is a sprite sheet, which is a sprite component that's responsible to get that sprite and rendering in the screen. There's a lot of math calculation here because, yeah, there's documentation. I'm going to open source all of this, by the way, so y'all can see. I'm going to put way more comments on this, so it's going to be really easy to understand what's going on. But yeah. The way I exported the sprite, I had some errors, so I fixed it here. But it's basically a sprite component, so this is what you need to know, that I'm putting in the center of the screen. And I'm going to switch back here to, I'm going to put this one. Yeah, so this is what it looks like, pretty much. And I'm dragging around. And as I drag around, the ship rotates with some kind of stage. But one thing that really annoys me about this sprite, it is not black and white. And let's suppose I cannot edit the sprites to be black and white. I want to do that via post-process. It's pretty simple. I have a shader that is, I think it's some of the simple shaders we have is the ship fragment shader, which is this one. I'm creating a gray that's an average between R, G, and B from the texture, and outputting that, basically. All right, and how do I apply this? Let's do some kind of live coding. Basically, some kind of live coding because I'm using snippets for everything. So it's going to be, oh, that didn't work. Oh, no. GC. Oh, it did work. Nice. Basically, I did all of this to make my ship go black and white. If you do hope this is going to be black and white. Yes, it's monochromatic now, not the details. The details now are not brown anymore. Super cool to see. Nice. So we have our first introduction to the words of post-processing on this game. But now I wanted to show you also some other things. Yeah, I think I'm going to just show how I made things isometric. Yes, here we go. Let me just import this from UI. And live code, boom. So basically, what I did here, I have this component called ground. And this is inside of this is my own component. I called it isometric plane component that basically transformed the children of this component, transforms it into a perspective that is kind of isometric. And as I rotate in the game state, I rotate the camera. I also apply these transformations to the children. So basically here I did put a rectangle component that's green-ish. In the center of this ground that has this isometric plane component, and it makes this isometric. This is going to be very interesting in the future because you can change the elevation of this isometric and make things go increasing in altitude here in this board. But yeah, that's pretty much it. Let's undo all of that and go to the second step. But before, let's go to the presentation because I want to mention some things. Here we go. The next concept we're going to put is weight maps. Basically, as you can pass numbers and images to shaders. Images can also work as numbers parameters because every pixel will have a vector for if you sample that specific pixel. So you can use those values to apply different behaviors to the different pixels of the output of the shader. Because every uniform you pass is the same for every pixel on the screen. So if you want to pass different values to each different shader, you do that through maps. This one's a very interesting one. It's called normal mapping, and basically the colors of the mask will define the behavior, in this case, the depth of this of each part of the output. But we're not going into 3D this way now. I'm gonna use weight maps just to render a basic, I'm not going for photorealism on this game, so a very basic wake for the ship in the sea. So I'm probably gonna put the wake in the ground. Let me see. The ground here has a lot more of content, has this position components that has this true wake. I think it's better if I only show, oops, I thought I was showing the code. Sorry. Here we go. Now this is how it looks like. It has this behavior. I'm basically translating this. But these two components that I add here on the ground has the wake, the outer wake, and the inner wake. They're basically painting a parabolic shape of two different widths, some combining in some ways, excluding some other things, just to have these very specific colors up there. But I don't want to render those colors because, first of all, because they're ugly. It's green, and what the heck's going on? But I'm going to use those as input to a post-processing. But I'm not going to render that. I'm going to render something instead. Basically, let's go back. I think it's ship wake. I'm going to make this a post-process component, which is also a position component, so it's fine. Post-process component, but this one requires, oops, let's fix the links, requires a post-process, obviously. Let's just see, let's go. So we have a new post-process. I called it the wake post-process. Receives a fragment program and a game as parameters, obviously, because they need those values instead. But what's happening in this post-process? First of all, we keep time, so we have updates, we keep track of time, and we will pass this to the shader because the wake moves. So whenever you have a shader that moves, that has some kind of movement, it's nice to pass time. So we'll be able to compile displacement, to compute displacement of the things you're rendering, and they'll be animated. And also, since I'm sampling the subtree, I'm basically using the pixels of the rendered masks there. I also need to pass pixel ratio because the subtree renders in the real physical size. So basically, the sizes, the pixels I need to sample has to be corrected. And yes, I'm passing the normals here and painting in the canvas afterwards. Let's look at the shader a little bit. Don't ask me questions about those shaders because most of the things I either copied from Shader Toy or just randomly tweaked values just to until it looked like something was useful. But yeah, we have a very nice way to render some noises in the screen. So whenever you have some kind of a form that feels like it's organic, should be organic, should look like real life, made by nature, usually you want to put noise and some kind of random value to create all this type of all different types of forms and everything. Yeah, I think pretty much it. Let's see how it looks like. And it looks like that. We have a little wake. Okay. So time to go back to the slides. Yay. Slides. Not working. Clicker. Oh, Keynote just froze. Fun. Next part, we're gonna do some 3D. So what's I'm gonna do? I'm gonna use a nice technique, a very, very nice technique that crazy shader people invented, and some even crazier people are really abusing it. So basically, ray marching is a way to render 3D forms using only shaders. And in our case, we have to use only fragment shaders. And yeah, how this works? Let's have a quick crash course on ray marching, because this is very complex. I linked some articles in the end that you totally should read if you are interested in this. But basically, it works like this. You know that I just explained shaders. Each shader paints a different pixel on the screen. So basically, let's imagine that every shader is rendering one of the squares in this grid. So basically, the shaders emulate the process of, in each shader, each pixel is emitting a ray, and this ray is iterating through space. And with these iterations, it gathers information around this virtual 3D world. And all of that, with the computation of this loop, that we have to do a loop, in each step, we accumulate values, and out of that, we get a single color. And with all of this craziness, people are able to render 3D stuff. So in each step, it runs what's called an SDF, sign distance field. It's basically a function that returns the distance of that point in the 3D space along the ray, that distance to the nearest surface, or to the nearest surface of a specific form. If you have a scene in this 3D world with several forms, you will have the distances, and you'll be able to compile the distances to all of these forms. And if you're inside of these forms, there's also a signing for that. I think it's negative in some SDFs. Yeah, with this basic concepts are great, because with that you can abuse and create fantastic stuff. So with this basic concept, people are creating some of the most amazing things. I think specifically this first one on the left, this guy is crazy, because this shader there fits a tweet, 144 characters, and look like that. Yeah, it's these people are crazy, and we have all the different types of explorations. And this last one, if you ever browse it, Shader Toy for 5 seconds, you'll probably stumble on this. It's fantastic. It's just the behavior of a sea. We can use that, right? I mean, it's a ship game, and we can use a sea. So yes, basically that's exactly what I did. I ported this to our Flutter thing. I said I was not going to photorealism. I think I'm going now a little bit. I tweaked it a little bit to fit the look of what we want for our game, which is basically black and white, and tweaked the perspective. And yeah, this kind of shader is super cool, because you can use tweak the values to simulate where the camera is looking. Super interesting. Yeah, let's go to the code again, I guess. I think I'm gonna transition to this. And I'm just fix whenever I broke there. All right, I didn't put the post process yet, but let's plan a little bit. I want the sea to be where it's blue now. And on the game level, I have the creation of the camera, and the camera is basically putting this bluish kind of rectangle behind everything in that camera. So it's basically a backdrop. So this is where I want to put the post process. So since this is on a camera level, you don't need to use post process always on components level. In this case, I have the camera. I have this specific post process to it, and yeah, I think I can use 3C. Oh, here we go. Did I destroy the code? Yes, I did destroy the code a little bit. God, I hate live coding. I don't know why I do that all the time. Yeah, did I break it? Yeah, I broke it. Let's go back. I don't know why I broke. Oh, yes. My constructor doesn't have a body. I didn't pass that interview. Here we go. Oh, now it goes GC3C. It sure broke. What's wrong here? Sorry? Sorry, 2 bodies? Line 38. Yeah, I'm not saying it. Can you come help me? Wait. Let me go. All right. I think. Thank you.
It's just after this.
Yeah.
Yeah, you didn't have the, and now. Yeah, you're done.
Thank you. I totally didn't see that. Yeah, let's see. Whew. Thank you. So Dart constructors, this is the new theme of the talk. I thought, oh, no, this time I'm going to use the snippets. Nothing will go wrong. It did. All right, so we added the post-process to the camera level. And what this post-process does? Well, it will rasterize the subtree. This one will render the subtree on top of whatever I'm painting. So basically, I'm painting the result of the shader that doesn't receive any image as an input, only numbers. And I'm render everything that's inside of that camera, in this case, the ship and the wake on top of it. And it looks like this. Woo. Yes. Yes. Thank you, Shader Toy guy. You helped a lot. So yeah, it was really nice to tweak. I kid you not, I spent the whole last week tweaking the values of this because it's so addictive, you know, you change something and you change how the waves behave. It's super fun. And it's totally math, and as you tweak, you understand how the shader works. I totally recommend that. And yeah, I sync it with the game state where is the camera looking at. It's also synced with the wake and also synced with the ship. So pretty good. I think this is pretty good to whatever we wanted. How many times do we have? 10 minutes. Let's speed run this. Because, well, it doesn't make sense that this ship has funnels. It doesn't have a smoke. So I'm just this GC4. Yeah, I know. You are not supposed to see this code. All right, let's go back to slides, actually. Everything went dark, and back to the beautiful sea. Here we go. Now, the step 4, we're going to add some smokes. For that, we're going to use 2 different techniques. One is differing, and the other is ray marching. But it's a different type of ray marching. It's called volumetric. Instead of rendering surfaces, this one will be rendering volumes. And volumes means anything that's like a fog, a cloud. So anything that's not has a clear surface, it has a fluffy surface. This is the kind of stuff that we will go. I actually created a shader out of a tutorial for this. So I posted on Shader Toy, is also on the code, and also I'm going to link in the end for the people to learn, and has a step-by-step on how things go. Not going to go deep on that because we have 10 minutes, and also ray marching is so good. You could have a conference out of the ray marching, so great. Not only a talk about it. And the other one is differing. It's basically a technique of creating patterns that fixes some problems like color bending, but also is really used on printing presses because you have a limited amount of different tones of colors. So this is really easier to create impression that there's a gradient with more colors than what actually it uses. So we really use it on printing, but also I'm gonna use this to give a retro look to our cloud. Yeah, for this I used something that's called a Bayer matrix for differing. Yeah, also link it in the end so you can gonna go deep on it. So basically this talk is always tiptoeing on concepts, and then you can go deep if you wanna on its separated thing. All right, let's go to code. Boom. Code ship. Ooh, VS Code crashed? No. It's here. Lovely. So basically, we have a new fragment shader, but also we have some new components. And in this case here, we have the smoke particles. So it's not rendering anything. Let me show the demo and the code at the same time here. Here we go. So basically, we have this component that has that in every second or so, in this case, I have a tick of an interval. It's basically almost a second, around a second. I use a random to not go about that. It spawns a component that's called a particle. And this component uses, I think it's the best API on Flame. It uses effects API to apply movement to that particle. So this particle will be moving for about 10 seconds to a specific location. So basically, it's being used here. And this effect is going to this coordinate. And then it's going to disappear when the effect is complete. So basically, I'm creating smoke particles here. So what I can do here, I am on 50, yes. So what I can do here is to, first of all, let's make the smoke particle just so we can visualize there. Let's make it let's make it a debug, to have a debug view. Basically, we have this very nice debug view of components. It renders this thing, so just we can see where it is. Oh, it's quite dark. It's really hard to see, but let me see if I can zoom in. Can we see that there's smokes coming out of the funnel? If I rotate, it will be easier to see where they're going. So basically, the parent component doesn't translate in this axis, along of the ship, but the child one does. So that's why we see agglomeration there vertically on top of the ship. So yeah, we have particles. This is a great way to exemplify another technique that we can use with post-process, which is post-process components that don't render anything. And these smoke particles don't render anything. We just want one thing from them, which is their coordinates in the screen. So here I'm going to add another post-process to the camera level. So let me change to the code. Here we go. Let's change to the code. And on game, oh well, we already have a post-process on the camera. Can we add more? Totally yes, because you can nest post-processes. And in this case, you have a very special one, which is the post-process group. Let me see, what's the snippet? Yes, GC4H. Boom, here we go. So we have the previous C smoke post-process over there, and C post-process and the smoke post-process, and they're being run in sequence. So basically, we're going to run the C, which basically doesn't rasterize anything, so it's fine. And then I'm going to put the smoke on top of it. So basically, this one, I'm not going to go deep on that because of time, but yeah, we pass the different values of the particles, including their radius and their centers, and their opacity that varies as they go along their animation. And this, let me save and update. Let's see how that looks. Yes, let me remove the debug mode. Ugly. Here we go. Yes, so we're rendering 3D stuff on Flame. Wow, Flame 3D. But this is a different 3D. We're gonna have a workshop of doing actual 3D, not ray marching, but with meshes and geometry tomorrow. The workshop. Go. Yeah. So basically, we have this, but we still have to add differ. So let's, for the first time, write GLSL code here. No time? Is it over?
Yeah, 10 minutes.
10 minutes.
I go.
I can do it. I can do things with 10 minutes. Is smoke. I didn't say that. Delete. don't say that, Mangirdas. Yeah, so we have JavaSL here, and I'm gonna use a snippet. Woohoo! In this case, oh yeah, this one, GC4. We have a differ algorithm here using the volumetric thing, the Bayer matrix thing, and it's basically look like this. Can you see the differing? Yes. Oh, that's great. So basically, we added that after all of the smoke was completed. So you see that the differ is not affected. The position of the dots is not affected by how the smoke goes. And this is a really nice effect if you want to have that look, like that retro look on games. Because it's being run after everything, so it's not affected by them. All right, and the last one, it's pretty simple. I think we just have to make this game look a little bit more, older. So basically, in this case, I'm not even going to change to the slides this time. Here we go. All right, and I'm going to add a new post-process to the camera. GC5 age. Here we go. Another post-process. This is so simple. I think it's the simplest one. All right. Basically, we're going to add a vignette and a sepia color to make it look yellowish and have the dark round. So it will look like an old movie about the war. I'm going to save it and let's see how it looks like. Here we go. It looks like pretty much like this. Yes. Looks quite old. So let's just roll back a little bit. So we learned how to, first of all, we learned how to make a existing texture, like a sprite, change its look in real time. We learned how to use noise and other things with weight maps to create a wake ship. I don't know if you noticed, but where it was green flows faster, where it was red. This is one kind of parameterization of pixels like that. We learned how to steal shaders from Shader Toy to create C level. We also learned how to use volumetric array marching combined with flame techniques, the isometric thing, to create this 3D effect. And we also learned how to do a vignette, which was pretty simple. But anyway, I really hope y'all could see what's possible and what's cool things we can do when we can take different tools, combine them together. Yeah, that's pretty much it.
Such a pretty presentation as always, and always overtime.
Sorry.
But really good, really good. No, so if you have any questions for him, grab him at the party later today. And we're gonna just quickly change computers here, and then we're gonna have the Flutter Grimoire, a practical guide to your first PR. So if you're scared at doing or don't know how to do PRs directly to Flutter, then stay here and listen. And downstairs in the studio stage, it will be Flutter Goes to Sea, building the next generation marine interfaces in Flutter. All right, time for the next talk. And this is from no one less than in some circles, she's known as the Cupertino Witch or the Cloud Witch, which you might see why soon. And this talk is about a practical guide to your first Flutter PR. Give it up for Jimmy.
Hello, everyone. It's so nice to have you all here. This is my first time giving a talk, actually, but I'm super excited. Right, so quick introduction. This is the Flutter Grimoire, or a practical guide to your first PR. I'm going to go into the why in a second, but first a quick intro. So, my name is Jamie Kerber, also occasionally known as the Cloud Witch. I am a senior Flutter engineer. I began working with Flutter in 2018. I do have a background in game development. That's where I got my education. That's how I actually got into programming in the first place. I am currently consulting for Very Good Ventures, and my main project at the moment is developing a Dart game engine for Toyota Connected North America. So, why the Cloud Witch, and what's up with this whole aesthetic that we have going on? So, if you really think about it, isn't coding just witchcraft? I mean, we have arcane words and symbols that we all use. We adopt repetitive rituals to get stuff done. There's demons involved, I mean, spelled a bit differently, but still the same thing. We summon them to get our job done. And it's all about getting magical rocks to do our bidding. Because, and sometimes there's prey involved, of course, as with any software project. And what are CPUs if not literally rocks that we tricked into thinking? By first flattening them and putting lightning into them, or whatever the hell is Intel doing these days. Before we go into the actual talk, I would like to invite you for a brief moment of reflection. Raise your hand if you've ever had an issue with Flutter that you wanted to fix. Okay, that's over half substantial. No, keep your hands up. This is gonna keep going. Keep your hand up if you felt like you had an idea on how to fix it. Okay, still a decent number. And keep your hand up if you were scared to actually go and do it and submit that code. Okay, some hands went down, so it means a lot of you are very brave, which is commendable, but some hands are still up. Good. Now, those who are still having their hands up, remember what you do. We will get back to you later. And to the ones of you that have had your hand raised until the very end, this is the talk just for you, so I'm very happy you came. I don't know why it's not animating. Okay, there we go. Figure out the GIFs. So, what is a PR anyway? So, according to GitHub documentation, a PR or pull request is a proposal to merge a set of changes from one Git branch into another. In a pull request, collaborators can review and discuss the proposed set of changes before they integrate them into the main code base. And as you know, Flutter is a community project. So even though you have a big company like Google working on it full-time with a whole team of engineers, they do depend on the contributions of the community. So whenever there's stuff to be done, of course, some of that will be taken care of by the core team. Some of that work will be picked up by us, because a lot of us have spent many years working with Flutter, and during the time we have sort of acquired that experience. Sorry. But just because we know how to code, it doesn't necessarily mean that we are familiar with the whole pull request process and code contributions to large open source repositories such as Flutter. So I'm going to tell you a short story. I was one of those people. I had built multiple commercial applications with Flutter. And as you gather that experience, the small, tiny annoyances like start to build up. But at this end, I had the knowledge that Flutter is an open source project and I could contribute at any time. But I was like, no, it seems a bit scary. Like, what if people don't like my code? Stuff like that, just usual self-doubt. But then I ran into this very interesting account on, well, what used to be Twitter, which was called Flutter Merge. And in there, I could see that whenever someone was pushing and getting a pull request merged, their results would get announced. And it would keep popping up, and I would see, oh my God, there's so many wonderful members of the community contributing on a daily basis, like multiple commits coming in per day, and a lot of them were solving problems that I actually had. I said, wow, that's amazing. And not just to, see that this kind of work is recognized, but also to realize that virtually any of us can make such a contribution. Because initially I thought you have to be a hyper-skilled engineer to get this work done. And sure, that is of course important, but it turns out that with enough effort and a tiny bit of knowledge, basically almost everyone with a certain level of experience can do it. And then of course there's the memes. Some people merge Flutter PRs to resolve issues, and others merge Flutter PRs so Flutter Merge mentions you. Thank you, Anton. So, why should you submit a PR? What are our reasons, and what can we benefit from submitting PRs as developers? Well, reason number one, you can fix, add, or improve whatever you need, as long as it aligns with the general direction of the Flutter project. If you submit a PR that said, well, there were too many bugs, so I deleted all the code, that's probably not gonna fly. It's gonna get closed before you even get a first review comment. But if it's something that you know that more people than just you might want to use, then there's a very good chance that not only that will get merged, but you will also get the help and support to make that happen. Well, number two is experience. Oh, yeah, forgive the number one. I did not listen to the part of Slava's talk about not doing your slides 30 minutes before presenting. So the experience you get from it is, okay, let me put it this way. Flutter is a very large-scale project developed by Google, which is, a company that has a certain set of rules and standards. That's how they got to be where they are in today's market. And if you want to contribute code to Flutter, you have to follow some of these rules. And even though some of them might seem tedious, they are all there for a good reason, because they help us deliver great quality products. And at the same time, having contributed, actually having gone through that process and having gotten your changes accepted is actually quite an achievement, because given that there is such a high requirement, being able to successfully complete that process means that you possess a certain level of skill, which can be considered valuable, not just by the community, but by, wink wink, potential future employers. So if you do submit PRs and they get accepted and you go through the whole thing and it results in, people being happy, you might want to put that on your resume. Just a tiny bit of advice. Reason number three is recognition. The deal there is you actually can, kind of like we showed with Flutter Merge, you can get, you can connect with the community as a whole. Because sure, there's many ways we can do that. We can try to talk to people one-on-one, but by showing others, hey, this is what I did, I can do this, people might want to start reaching out to you, asking you for advice on similar issues, and that generally might lead to you being recognized as a former Flutter expert, which, let's be honest, who wouldn't want that? Another thing that, another way this manifests is, for example, whenever you commit something, like in this case, I committed the functionality of specifying different buttons, different sizes in the Cupertino button. And every time someone goes and reads that code, they will see your picture and name next to it, and they will know, oh, so this person did it, so if I need some advice on how to use it, how to learn how to do similar things myself, I could reach out to them, which is, the beautiful thing about an open source community. If you've done particularly well and your efforts go recognized by the core Flutter team, you might end up on what are the weekly Flutter notable comments, which is a Google maintained list of the contributions that have been recognized as the most valuable for the project and the community. These happen on a weekly basis. I don't think there's a limit to how many of them get in. I don't think there's a cutoff. But in general, this is a quite prestigious list, and if you have gotten there before, my hat goes off to you. Another thing is, well, the PR bot. So, quick note. The bot I showed you earlier was specific to Twitter. And, as that platform is very slowly driving off to the sunset, to put it mildly, some community members have been moving to Blue Sky, and I noticed, there doesn't seem to be a counterpart on Blue Sky, so I just went out and I made one. I'm ashamed to admit that it has been offline for a bit, but I'm planning on getting this fixed by the end of the month. So if any of y'all wonderful people want to, see your work recognized up there, it will be done soon. And, and if people notice you enough, then they might start making memes about you. So that's how that happened. And again, I think Anton really likes Drake memes, because this isn't the first one we've seen, and they probably keep going if you go to his profile. Oh, right, yeah, and it says, for the fans of Material Mike, if you don't know who Material Mike is, that's another open source contributor to Flutter that's, well, sort of my material counterpart. While I specialize in Cupertino widgets, he specializes in material widgets. Great. Now that we have a bit of a background, I'm going to tell you about how to submit a pull request. There's a lot of ways I could go about this, but the way I chose to do this is to take as an example one of sort of like my most comprehensive changes, and I will walk you through it step by step. The reason I had the idea to do this is because, like I said at the beginning, this process can be quite intimidating to many. And after having gone through that whole thing, I noticed, hey, if I think about it, this can be reduced to just a very simple series of steps. And if people know them ahead of time, they might be a bit less afraid of them. So that's sort of what I'm aiming to do here, because it's very difficult to find comprehensive material about what this process looks like in practice. So this will sort of go step by step, illustrating what the process looks like when you actually submit your pull request, and what are some of the steps you can take before it gets submitted. So as for the order in which I'm going to present those steps, please take them with a grain of salt. They don't always happen in a linear fashion. So we are going to talk about this Cupertino button styles and size that I implemented. Quick backstory on that. This was, well, basically last year, shortly before I attended Flutter Friends 24. I was working on a bunch of iOS-looking apps, and I noticed that the button that Flutter offered wasn't really quite up to spec with the latest iOS design guidelines, which meant that if you were to use Flutter to develop an iOS application trying to make it native, it would stand up just by the virtue of the fact that the buttons didn't look like the native buttons, which is kind of the point when you go for Cupertino widgets. So I decided to do this very fun thing, which I used to love to do when I worked at a web agency fresh out of high school. This was before we had stuff like Figma. So I would just get a very large Photoshop file from the designer on my team, and he would just send it to me and he would say, do this. So I would just look at that and try to replicate that pixel by pixel, because I just found it very fun. So what I did with this was very similar. I took a picture of how Apple displayed the new button designs, and I just replicated them pixel by pixel in Flutter until they look identical. And then I submitted my PR. This is sort of the comparison. On top, you can see the pictures straight from the Apple documentations, and on the bottom, you can see how the buttons looked once I implemented them. I would say pretty close. They were not 100% identical, but it was at a level where I was like, okay, I think I can be happy with this. So, first step, we start from identifying an issue. And this can be done in two ways. You can either go to the Flutter issues page, which as of today has, well, let's round it up to 12,000 issues. So, take your pick. You can just go through that and see, this looks interesting. I would love to fix this. So you just get into it, you read the logs, you read the comments, you try to reproduce it on your machine. And once that happens, you can start working on a fix. Or scenario 2, the more common one, what you do is, well, you just run into a problem yourself, the old-fashioned way. And, you can scream about it or write a fix, or usually both. So, step 2, we write the code. So, in that case, once I identified what needed to be changed, I went ahead and modeled those buttons, try and error until they look similar enough. And that's sort of what it looked like. These are just some extracts from the code. For example, I created a Cupertino button size enum, which would allow you to choose between the 3 available sizes. And then for the text style, there would be also different text themes that you would use to match the button size to the text size inside of that button, and so far and so forth. I just went through the whole Cupertino class until I had a working implementation. One thing that you might want to be wary of in this day and age is that while AI tools can be very useful, and I do recommend that you make moderate and healthy use of them, there have been some people recently, not specifically in the Flutter community, but in all the Flutter open source projects, that would maybe not necessarily have a lot of experience with things, so they would just see a bug and they would write to ChatGPT, hey ChatGPT, write me a fix for this. And very often those people would not even test whether they work or not. And then they would create a PR with those fixes in. And sometimes they would work, sometimes they would not, but it generally ends up with the maintainer telling you to stop. So my recommendation, to put it shortly, is go ahead and make decent use of LLMs if you feel like they help you actually being productive. But please do not write a whole PR beginning to end with just LLMs. This is because complex projects such as Flutter have very strict guidelines on how code should be written and defined and how certain things should be implemented. And very often the sheer number of those can be soul-crushing to a human being, let alone to a machine that simply doesn't know better in some cases. Step 3 is knowing when to stop, which sounds a bit counterintuitive after I told you to start doing something. There is a bit of a specific reason to this. This has more to do with the general process of PR approval. So let's say that you are trying to fix the button. And as you work on that, you notice that some parts of the button don't really work in dark mode. Like, for example, the part on the right was what we would expect to see, and the part on the left is what we would actually get in Flutter on the screen. But here's the thing. That was actually a completely different issue that needed to be fixed, because it wasn't just affecting the button, but a bunch of other widgets as well. And if I were to go ahead and include that change together with the rest of my fixes, well, 2 things could happen. One, if for whatever reason that PR were to be closed, people wouldn't benefit from the fix to this issue, which was plaguing other widgets as well. And another one is it could become very hard to decouple where one issue starts and the other issue ends. Because generally the thing that we're trying to go for every time you submit a PR is to focus one issue and one issue exclusively. At least that's what some projects demand, and I do recommend that for better traceability of the progress that you make. Again, very often if you start actually fixing multiple bugs in a PR, maintainers will tell you to stop. So a good idea is to stop yourself and notice that something else is wrong, create a separate issue for it, and then a separate PR. If that's blocking, you might want to take care of that second thing first, like it was done in this case. Fortunately, that other issue of the dark mode was a very quick fix, was probably just a couple lines, and it got merged within hours, which for the faint of heart is actually relatively short for this type of thing. Great. Once we have all of that down, we have written our code, we made sure that it's within a limited scope, and that it sort of does what we want, we just double and triple check. We test it out. We try it on different screen layouts, we try it on different devices, different screen densities, especially if we're working with widgets, because every device has like some peculiarities, and just because something appears one way on your screen, on the one that you're developing on, doesn't mean that it's going to look the same on all devices. So the usual good practices of Flutter UI development apply. There's a lot of lovely people, even included within the Flutter Friends, that have given much more in-depth talks about this exact topic, and I do recommend you give them a look. Once you have tested it and it seems to work, great. Then we're going to actually write automated unit tests. This is actually part of the Flutter project process, where whenever you submit a change of some sort that either adds functionality or removes it, the maintainers will ask you to make sure that you either add or remove or update tests to make sure that those features work correctly, even after someone else sometime in the future submits another PR that might or might not be touching upon your functionality, because then you don't want it to break. This is how such large projects make sure that things keep working, even when we're talking about hundreds of thousands of lines of code. Because if we were to do all the checks by hand, it would just become unfeasible. This is an example of the tests I had to write for that button. I'm actually not sure if... Okay, no, but those were the tests that were part of the Cupertino button. For those unfamiliar with them, the way they work, they're very short snippets of code. Sometimes it can be a bit longer, but usually they're within 10 to 20 lines, where you define a widget and you tell a widget tester to pump it, which is a way of simulating those widgets without actually rendering them on the screen, which is a process that the Flutter GitHub continuous integration system does automatically every time you submit some comments. But at the same time, you can run them from your own computer by simply going to the respective file. And if you notice on the screenshot, there's a tiny play button, sort of like on the left side of the screen. This is part of the Flutter plugin in VS Code, more on that later, which simply allows you to select individual tests and just like run them within a matter of seconds, and then you know if stuff works or not. Brief bit of advice, something that you generally might want to do is whenever you either change the functionality of an existing widget, you definitely want to run tests, all the tests for that specific widget. If you do some more comprehensive changes that might involve more widgets, then I would recommend that you run maybe not necessarily all, but at least most of the widgets for the respective category. You don't have to run all of them because that takes some time, although it is recommended if you know you have a powerful enough computer that could do this quickly. Even if you don't, the Flutter GitHub CI is going to take care of that for you, and if something doesn't pass, it will simply tell you. However, it is sort of quicker to do it on your computer, so please remember to install the Flutter plugin in your VS Code, assuming you use VS Code, of course. There's other plugins for other IDs as well, but I'm not particularly familiar with them, so I'm going to skip that. this one is probably the most frustrating bit and part of the reason why some people have tried to submit a PR and they were sort of like burnt by it and decided to, nah, I don't want to go through this again. But trust me, after we go through this, it's going to be a bit less intimidating. Still perhaps annoying, but not intimidating. So, as you submit your code, the reviewers assigned from the Flutter team will go through it line by line, review all of your changes, and leave you comments, either giving you requests for changes or suggestions in some cases, but mostly requests, which you actually have to comply with if you want your code to be merged. Some of them will be more important than others, the most important ones being like, hey, the formatter or the analyzer is reporting an error, or this thing isn't done super efficiently, try doing it this other way. They'll just give you like more practical suggestions, even though most of them will be already reported by those automated code quality tools. We're going to talk about this soon, by the way. But there's the nits. The nits are very, very small changes or annoyances that can be perceived by someone more experienced with the code base that are sort of like part of the project's inherent code style. And not all of them are automatically enforceable by a formatter or such. So you will simply have maintainers like telling you, hey, do this, do that, fix them. For example, in this case, all comments should end in a period, just something I didn't know at the time. So I would just like write sentences and wouldn't put a dot at the end. I just didn't really like putting dots at the ends of sentences, but I realized I had to compromise if I wanted to get my stuff merged. Other times they will tell you that when you write multi-paragraph or like multi-sentence docs, you should add an empty line between them. Again, analyzers won't tell you this. This is just a thing you have to know. If you submit code yourselves, you'll most likely run into those very specific things. Another thing that's a no is a double new line. They will also tell you to remove that, but if you know about those and you can take care of that before you submit the code for review, then everyone is so much more happy. You will not have to, be exposed to a lot of those like nitpicking comments, and at the same time, they will be happier because, oh, this person knows what they're doing. They're familiar with the code base and they're following our style, which will result in your changes being merged faster. Step number 7 is the formatter. This is something that comes as part of the Dart package, and you can run it from the command line by simply specifying the folder which contains your project and running like Dart format on it, and then that will simply go line by line and make sure that the general code style is respected. Again, this doesn't really fix everything, but like it roughly looks like this. For example, in this case, we had an example where we have like multi-line lambdas. They have to like the parentheses go in a specific order, and there have to be spaces between certain things. Stuff like that, it's like once you notice the patterns, it may become automatic to yourselves to start doing this, but otherwise what you want to do is to install the VS Code extension for Flutter, because what that does is every time you press save on your keyboard, it will automatically do this. It will format the code to match the guidelines of Dart and Flutter. So then you will not have to worry about this. Just please make sure to install the extension. It's very, very important. Another part of this is the analyzer. This will also not work unless you have the extension installed. So again, please make sure you do. And if you don't, this is the kind of thing you'll have to read through. The image in the bottom left corner actually shows you what VS Code would show you, instead of someone else consistently reporting, hey, fix this, fix that, which again can be a bit soul crushing to some, but if after enough times, But if you have your ID reporting that to you, then just another task on the list, and then you can just, in some cases, automatically fix them. In other cases, they're just like just a few seconds for each of them to fix that. Actually, this is one part where AI tools can be quite useful. They can sort of like recognize those changes, like those requirements for changes, and apply them automatically for you if it's something that cannot be fixed by the old school analyzer automatically, but requires a tiny bit of intelligence, but a lot of manual labor. Automation of this kind is actually very, very useful, and this I really do recommend. Step number 9, document your changes, especially if you're creating or changing the way certain APIs and variables work. For example, in this case, I created a map between the Cupertino button size enum and the sort of like padding or edge instance geometry for those buttons. Because as we've seen earlier, like those buttons, depending on which size they are, they will have a different set of like spacing numbers for their content. So in this case, I created this, this map, which was a public variable, and it was requested to me that they are documented. And also that since they originally came from the iOS 17 human interaction guidelines from Apple, that it was also requested that I include a link to the source of that, where you could actually go there and measure by yourself whether that is correct or not. And this is sort of like what it looked like. Normally if you were to do it, you would have a very simple enum, it's like name of the enum, the 3 variables, close parentheses, and call it a day. However, when you're building such a huge code base, you have to document that sort of thing for every single parameter. The way we do that in Flutter is by having comments with a triple slash instead of a double one. That way, every time someone highlights a such a variable with, or just any sort of reference with their mouse pointer, they will see that documentation popping over it. Step number 10, goldens. This is, I think there was another talk about this earlier today, and unfortunately I was not able to attend, but I hope some of you did, because that will be super useful to you. I'm going to keep this very short. Goldens, or golden tests, are automated tests, just like the ones for the code we saw earlier, that instead of working on code, work on images. Basically, ahead of time, the Flutter team will create a repository of reference images, known as goldens, that simply are pictures of how certain widgets should look in a certain configuration. When you go and make changes to those widgets, depending on what you're working on, some of those images might fail those tests, but that's not a bad thing, because what you would want to do is, let's say you are rewriting the way buttons work. When you do that, you would basically have a change, and then someone from the maintainer team would take a look at it, and they would tell you, okay, this is fine, we'll put a flag on this so this gets accepted. Don't worry, it's good. But if you're, for example, changing something else that's unrelated, let's say you're changing a property in the Cupertino button, but then something in the material button breaks, well, that means there's a problem to fix, so we go ahead and fix that. This is roughly what those tests look like. Most of you will probably not have to deal with them, but if you do, you have a comparison of a before and after, and then in this case that is a pass, because there are no, there's only a 0.08% change between those two images, which was not high enough to trigger an alarm, so that simply got automatically approved, and that was basically it. Step 11, submit. This is the end of the race. What we do here is we commit all of that code, we create a pull request, and as we do that, we write a description for it. The first thing is a summary of changes. We simply write a list of, we did this, we did that, those are the effects that this is going to have on Flutter itself or other people's code. Then if it's a PR regarding some widgets, you also want to submit a image for people to know what this is going to look like once this gets merged in. And the ideal and highly preferable thing is to include an example that shows people how to use this new widget that you just created or this new functionality in an existing widget. And once you have done that, you will be at the reviewer's mercy. And this is where we go back to the whole thing where you will be faced with people that will present you with rules and opinions that even though you might not personally agree with, you sort of don't have a choice because those people represent sort of like the single source of truth for the project and they sort of dictate the rules. Like we said, those rules are there for a very good reason. They are what keeps Flutter being the amazing framework that it is today, both today and for a long time to come. And that's why we have to follow those. So yeah, so you might ask yourself, why are those people complaining so much? They will like tell you, fix this, fix that, and if it gets enough, even they might realize, okay, this is getting a bit kind of mean. They might apologize. But again, since Flutter is such a large-scale project that many other projects rely on, it's really, really important that we keep those standards of quality, not just for ourselves, but for everyone's sake. There we go. And at the same time, you actually might learn something new. If you are used to, for example, mainly working on personal projects where you can do whatever you want, you don't really have a lot of constraints, you might have never had to learn some of those rules, even though in the long term they might benefit the project if you end up working, making it into something bigger. And by going through this, you will actually learn how and why those things work, which is another reason why I really highly recommend you do this. And please remember, the Flutter team has limited resources. There's hundreds, if not thousands of us in the Flutter community. But as far as I understand, the Flutter team is severely under 100 people, talking about Google employees, especially those who work on creating, updating, fixing Flutter day by day. There's really not that many of them, and their time is very, very limited. What this means is not only there's a limited number, an amount of people and amount of time that can fix those issues for you, but it also means there's a limited amount of people that can sort of like look through your things and help review them, which is why it's really important that you thank them, because when you do, they will be happier to sort of like help you in the future and create just a more positive environment for everyone. So even Wojtczak, who we know is a famous grump, who would not thank someone for a job that he's perfectly capable of doing himself, will thank his reviewers because he's unable to review his own pull requests. Thinking again at our first moments during this talk, when you were raising your hands, out of the people who wanted to make some changes with Flutter but were afraid of doing so, please raise your hands again. Okay, great, great. So please keep your hands up if you feel that after this, you might actually want to go out there and try creating a PR to fix or add something. Okay, well, I'm seeing some hands up, which is a positive sign. Time for QA, hoping I have time. I don't see anyone telling me to not do that. So, any questions? No questions? Okay, that's perfectly fine. Thank you so much for coming to everyone. A special thanks to the Flutter maintainer team who sort of like guided me through all of this, to the Flutter and Friends organizers that created this beautiful event for us to enjoy, learn, and teach at, as well as all of you for coming here. Thank you very much.
Thank you so much for joining us. And I guess it is panel talk time. The question is, where is the panel talk master? Oh, right. All right. So it's in 10 minutes then. Yeah. Perfect. Yay! bara köra på.
All right, everyone. I hope that you had a great day with some wonderful talks. So we're going to close off with a panel debate. So please welcome up Leushchenko, staff engineer at Tide. Filip Hracek, freelance iOS and game developer. And Ivana Katsevica. I was practicing this, I'm so sorry. Flutter lead at LMT, a special guest for tonight, as you can see. Then we have Slava Egorov, Uber TL of Dart at Google. And last but not least, our home witch in Stockholm, Jamie Kerber. Please welcome, software engineer at Very Good Ventures. Okay, so last year, during this panel debate, I asked a question to the panel and to the audience about if anybody had used Cursor. At that point in time, Cursor was very new, and I think there were maybe like 1 or 2 hands showing in the audience. So now, 1 year later, let's do a show of hands. How many people are using any kind of AI in their day-to-day coding? Okay, let's keep those hands raised. Out of you who are holding your hand, how many are using some kind of agentic coding capabilities? And still quite many hands. And how many are using background agent where you basically let go and wait for a peer to land? Not that many left. But obviously, a lot of things has happened in the last year. Every company, including Google, and also, of course, Flutterflow, they just launched Dreamflow, and Pooja is going to have a workshop on that tomorrow. And there's been all of these different kinds of AI tools to build apps. What are your thoughts on this, and what are your thoughts on how it's changing, if any, the role of software engineers? Unintentional mic drop.
All right. Well, well, first of all, I not only have thoughts but feelings, because I feel like it definitely changes the way we will be creating software, if not already. And I personally feel a bit upset because I genuinely love what I am doing, coding, sitting there talking to compiler. And now I feel like I have to do more code reviews and actual coding, which makes, I guess, my daily life less fun. So, yeah, definitely the way we write software changes. And I also sometimes am afraid to like share this opinion too widely, because it seems that every progressive developer is supposed to like AI, agentic coding, and so on, assistance. And if I am not fully on board, then probably I am like outdated, and yeah, should get my stuff and get out. But when being in this conference and discussing stuff privately in private discussions, I have seen that a lot of developers actually share this feeling and share the situation. So I decided maybe it should be spoken up, so a lot of other people also feel like you're not alone if you're not feeling like having a full buy-in and full on board with this movement.
So you kind of feel that part of the craftsmanship of development is taken away from you, and you kind of become an engineering manager instead.
Exactly. Exactly.
So do you also feel in this sentiment, any one of you as well? Yeah, lots of people in the audience agree. So Ivana,
Yes.
you have been extensively doing AI workflows with programming the
Yes,
past
I
year.
have tried some things, and I think it's not just the craftsmanship that it's taken away, but also the fun and the satisfactory feeling that you get after you fix the bug by yourself, spending 3 days on it. You get this dopamine high of it, but if you just let your copilot or cursor or whatever fix the bug, you don't have this feeling anymore, so it's not as fun. And also I wanted to add to what Anna said about the code review, that there is nothing more frustrating than receiving a PR that you see is clearly written with AI, and now you have to read this garbage code and review it and comment on those lines. That's the frustrating feeling.
So it brings up some conflicts among your colleagues.
Yes, yes.
All right. So I think it's interesting that also, like companies like Google also mentioned that something like a 2-digit percentage of code is now written with by AI, right? So I wanted to ask Slava. Of course, you're in your very, very highly specialized domain of compilers and compiler-related technologies. How much AI usage do you have in the Dart team?
Well, I don't know how much individuals use it. Different people try to use it. I try myself. I find it very good at things I know nothing about, like making Flutter UIs. I tried once to take a screenshot of a mobile app UI and just feed it to Gemini and ask it to recreate it in Flutter, and it did quite well. But then if you ask it to add interactivity and if it's complicated logic and stuff like that, things start to fall apart a bit. And I think the same happens with any sort of complex thing that you try to make work. At least that's in my experience. Like I ask it to do a change to a VM out of curiosity. I try periodically, and then it actually manages to do some stuff, but then fails in a spectacular fashion in the actual core implementation of it. So my opinion is very mixed on it. Yeah, I think it's, yeah, as I said, it's pretty cool when it works, and it's pretty depressing when it does not. And when it does not, and you then get into this failure loop of trying to make it work instead of just creating this code yourself. It's, yeah. I think when the dust settles in a couple of years, then we should have this panel again and look back and, yeah, we figure it out. If global warming doesn't destroy the planet before that.
Or AI.
Oh, I think it's not going to happen, but yeah.
So for my position of being a manager, I've had the opposite feeling, because I almost never have time to properly code nowadays. But I am very much still a programmer at heart, and I love to tweak the product a lot. So in the past, whenever I got some feedback on our product, I needed to create like a ticket in our ticketing system, and it would be buried in a huge backlog. And some months later, somebody will find it and like, oh, now this is not relevant. Or you at least need to plan it into a new sprint, etc. But now I feel with background agents, whenever I get feedback, I can all of a sudden just spawn a background agent, post whatever it was, like we need a button that does this, or oh, can you add a tooltip for this thing to show like a full message from a concatenated message, things like that. Small tweaks. And then 10 minutes later, there's a PR. And I can verify the result and check out the code. So for me, it's been really transformative in a positive direction, where I feel like I can finally be productive with code, although I'm not typing it myself. I can still I can still code in a different way. But what I'm really worried about is how this will affect the job market, especially for junior engineers, because there's this concept of the singularity, right? At which point in time is it that if you start studying or start learning to become a really good software engineer, to understand the whole stack of how things work, so that you become proficient enough to be in a senior software engineering position, if that takes you 3 years or 5 years, at which point in time will the AI have been accelerating so fast that if you start now, when you're done in 3 years, your knowledge or your skills are already obsolete? I kind of feel like there is this kind of problem for junior engineers that come out in the workforce now, that they're good enough to code, but the AI is kind of like taking the opportunities that they would have by having a senior engineer creating a bunch of agents instead, if you get what I'm saying.
So I think people should be aware of that there are two different visions of the future. One of them is like, okay, the same way that you can use ChatGPT, in the future you can use AGI, right? And it's as smart or smarter than a normal person. And it's available for everyone. And that's one possibility. The other one, and a lot of people that are much smarter about this than I am, think that that's a more probable option, is that maybe we will have AGI, but it's like it takes the computing capability of a whole data center to be as smart. In which case, it's not going to be replacing, or it's going to be replacing like a board member once in a while. Like a company will hire a data center for 5 hours to go through something, and that's it. And so like it depends on which version you subscribe to. If it's the one where everything is AGI, then we're all finished, right? Like if you can have AGI running on your phone, like there's no that future looks very different than what we have now. But if it's the other one, then I don't think really people should be stressing too much about it. Like if you look at the current state of AI that you can run on, like for an everyday person, it's a different kind of intelligence that what we have. You have to learn how to work with it, but you still need to be the one who knows what's going on to make sure that it doesn't hallucinate like terrible things. And I've seen like research that says that if you give up and just say, all right, I'm just gonna learn as a junior, I'm gonna learn using GPT or whatever, then these people don't really learn because they don't do the small stuff that then they can build upon.
Yeah. I actually had the opportunity to see how education is adapting to this in the modern age. When working on my previous startup, I was developing a product in Flutter which was targeted for software engineering education. So I got to interview a bunch of teachers and students about the topic of AI. And what I noticed is that there seems to be a form of semi-healthy compromise occurring in that field, at least at the university level. Basically, if we look at how AI performs in the task of coding, we can see that it can be quite effective at the what, but very inefficient at the how. And I noticed that some of the teachers picked up on this, and they tried to reformat the curriculum to accommodate for this to an extent. So use of AI in some IT courses is permitted, but only as long the student can do the reasoning themselves behind the design of a program, behind the structure of it, and can explain the what. So it's not like the AI is sort of like replacing the junior developer, but rather the junior developer still needs the same level of knowledge. Like being able to supervise the output of an AI is just half of the bare minimum, and the other half of that is being able to provably reason on structuring, on like being sort of the shot caller, the decision maker in software architecture when directing such a system. I think that for now it's definitely a good direction because we see a lot of products or proposed products that are marketed as a full replacement for both tasks. And many of us have probably seen quite a few viral posts on the internet showing how those same products spectacularly fail at those tasks. So I think that as long as we make the right space for AI within our workflows, we can sort of have like the best of both worlds. To give you a short example, the way I use AI in coding is just as a very smart autocomplete. I'm still in control of where every section of code goes, what it's supposed to do, how it's supposed to achieve it. But if it's something like, for example, hey, show me a dialogue that has an OK and a cancel button, I can probably quite easily ask it to do so, and then I'm still in control of the artistic direction of how that button is styled. I don't describe it to the AI, hey, make it look cute or make it look cool. Instead, I go and tweak that parameters myself still. Because that part of the work is fun. It's probably not fun or enjoyable to, have to write the same 10 or 12 lines of code that you need to build a dialogue yourself over and over and over. I think some parts of this can be automated away, so we, as people, as human developers, can focus on the more interesting challenges. And what those challenges are will, of course, vary with our experience level. So junior developers will still learn on how to perform those simple tasks. They will still do some of it. And as they become more experienced, they will offload different portions of that work to the AI, but they will continue supervision.
I think you had a really interesting take there as well on education. Do you think, from what you have been able to observe, that through like augmenting or supplementing the learning that the students do with AI, think that like they learn faster? Do you think that you can, like, in the same amount of time, do you produce more, like a higher quality knowledge, since some of these like more or less mundane things like syntax is glossed over, while you can focus more deeply on abstractions and patterns and how things work under the hood?
I mean, based on what I observed, it's sort of a net neutral, because while some parts of development are indeed made faster by this, that amount of time that gets freed up goes to learning how to work with those tools, those very specific products, because sort of like each of them has like, their own peculiarities. So it might be worth it in the long run, but when it comes to just the basic courses that universities offer, the result is basically the same.
So, and I'm wondering really how this is affecting the job market already. Another quick show of hands, like how many have, like looking at the hiring plan at the company you work for, how many have had the hiring plan change in the last year after the advent of AI, or is it basically staying the same? So let's do a show of hand. How many people think hiring has changed? Okay, not that many. And how many think that hiring has stayed the same? Okay, that was surprising for me. So there was a majority of people that think that hiring haven't changed.
Yeah, for me it's surprising as well. Can we also ask how many of your companies are hiring for junior positions right now at the moment? Yes, see, so I think the market for the junior positions was already in a bad condition even before the whole GPT revolution, but now it's even worse. So maybe the hiring has not changed, but it didn't improve either for juniors especially?
But I think it's the world is in a complicated economic state right now in general. So we should not over-index on thinking that this is necessarily caused by AI. I think people who make decisions for how money flow often use AI as an excuse to squish some stuff and say we need more efficient senior engineers doing a work of 5 people in one head, right? That is, I think, what's happening. At least that would be my analysis of it.
One funny side effect I have observed happening at some companies is how some human job positions were created because of how unsatisfactorily AI has performed in certain tasks. Like some people got a bit overexcited and went out and replaced a bunch of roles with AI. And when they realized their products are falling apart, they were like, oh shit, we need some experienced humans fast. So
yeah, there's definitely been some oh shit moments, for sure. Okay, let's move on to another topic, a quick one. So we had Albert downstage talking about writing widgets without material. And as most of us probably know, there's an active effort from the Flutter team now to take portions out of like basic widgets that are currently in material and take them back out into the widgets library. So what are your thoughts on this? Is this like something that's long overdue, or will it matter in the daily work that you do?
Yeah, I was an advocate of this for a long time, and I'm super happy to see this happen. And I will try my best to support this in my open source endeavors as much as possible. But I do think there's 2 very interesting benefits. The main one being for accessibility, because right now the amount of work that was required to implement good accessibility in Flutter widgets was effectively duplicated. I mean, sure, you have a material button, a Cupertino button, and from an accessibility standpoint, the work they do is identical. And yet we've had to maintain 2 separate implementations unreconcilably of a button. But I think with this, it's going to be much, much easier to iterate on that and bring accessibility to a broader array of widgets much more quickly.
Yeah, that's a great point.
Yeah, I mean, for a long time I thought it would be best to just have so I think a lot of the apps that are built with Flutter are built with Flutter because you want a custom UI, right? So you don't want to look like Cupertino most of the time. So I thought that would be the way. So basically material being so flexible that you don't, like, it's still called material, but you can always like override it with whatever you want. And it's to an extent you can do it. But I, of course, welcome this because this makes it much easier, much more straightforward to do really custom UI. And I think, again, that's the sweet spot for Flutter.
Do you agree in the audience? Do you welcome this change? Hey, great. All right, so that was it for the panel today. So I'd like to thank you very much for joining us and give them all an applause. Okay, so now Lucas is coming out. He has dashes in his hands, and I don't really know what's happening, but take it over, Lucas.
I don't know what's happening either. I just thought it's like 6 o'clock, and you guys have like been here all day, so you're probably pretty tired. So who in here doesn't have a dash and wants a dash? Okay, let's see how good my aim is. Last year we had a catapult, but that one worked even worse. And if you come to the party, we have 50 more. Oh, no. And the party, it starts at 7 o'clock at the Slaktkyrkan. The map's location is in the app and on the schedule. Yes.
Can we get some slides? Can somebody in the tech booth? Yes, thank you. Yeah, so, okay, next up, first we talk about tomorrow, then we talk about the party.
Sounds good.
So we don't get overexcited. So workshops tomorrow, we're going to have them in 2 locations. One workshop from Sasha unfortunately fell out because he felt sick. But tomorrow, first we have at the Matchstick Palace. You see the address here, and it's posted in Slack as well.
And emailed out to you and updated on the website and soon in the app.
Great. So we have 2 workshops, one by Pooja on building Flutter packages and modules visually. Hint, hint, it has something to do with where Pooja is working. And the next workshop is about vibe coding with Flutter. So let's do the next one. And the other venue for the workshops is at Devo Team, who's sponsoring us with the venue for the 3rd time in a row. Yes. So Devo Team's a place can be a little bit tricky to find. So you can see here on the photo below, it's inside of this corner, and you walk in right there. And there we're going to have a workshop about building your own Flutter AI Sidekick, translating Figma designs to maintainable Flutter code with Widgetbook MCP, and going into Flame 3D. That sounds cool. So in case you didn't get a workshop ticket, then tomorrow we have additional activities with 2 hackathons. Lucas, you want to tell about
Yeah, sure. So if you are accidentally a little bit hungover tomorrow, then this is the perfect spot for you to be, because it's a very like chill out area. It has some like small arcade games and sofas, and it's not much of presentations and stuff there. It's just we sit there together, and you will get like basically the whole Flame team is here. So if you're building a game, you can get a lot of help with that. And we've built this open source library for the badges, so you can hack around on them tomorrow. And yeah, that's from 10 to 4.
Yes. And we have a trophy for the hackathon.
Yes, 2 trophies, I think. Even.
2 trophies.
Or maybe 1. I don't know.
I think we only have for the game hack.
Okay.
This game.
Yes. The badge is trophy enough.
Exactly. So now let's talk about the party. Hey! So in case you haven't been before, it kind of looks like this. It's a chaotic and very fun mix of a regular party and a LAN party and a coding workshop, I guess. So we're going to have tons of stuff there. There's going to be a tattoo artist. If you're going to want to get a flash dash tattoo. And we, of course, have the big spectacle, which is Flutter in the Dark. So if you haven't seen it before, you really should come. And you're going to find the venue. It's called Slaktkyrkan, the Slaughter Church. It actually is called the Slaughter Church. So the party starts at 7 p.m. and you can go there by taking the green subway line to the station called Globen. So it's really fast. Like the subway takes like 10 minutes, and then the Google Maps adds time for walking.
But you don't have to be there at 7. There is no food there, so eat dinner before. And like the Flutter in the Dark competition doesn't start until around 9. So yeah, you don't have to feel stressed to get there.
Nope. Okay, great. So that's the end of info time. So now it's time for thank you time.
First, it's time for where is Elias actually? Yeah, Elias, come up and take the. Oh yeah, bring the merch first. So we had the competition yesterday too, right? So where is the team that won the quiz, the pub quiz? Oh, right. That's he's the only one that knows that, I guess. Did you have a team name for who won? Okay, but do you know who won? The suspense is killing me. N-A-I? Okay, so can you come down to the stage? Oh wow, it was really even. Okej, men det vet de inte om. Så. Okay, so like half of the conference was apparently in this team. Yeah, so you just stand in a line in randomized order. And so the pub quiz, it was sponsored by Posthog. So give a big applause to Posthog. And now, starting from the front, you get to choose one of all these items here. And you have about 3 seconds to make your choice. And tonight at the party, we will have a swag table with a lot of leftover swag, and swag we haven't put out yet, so don't miss out on that table. All right, another applause for the pub quizzers. And now, for the next group that have done a tremendous amount of work, can we get the speakers up on stage? You get to put them on yourself. Oh, you already got one.
My black and white vibe. There we go.
Did everyone get one? All right, give a round of applause for the speakers. And then we can get the sponsors up on the stage. Woo! And the ambassadors. And the photographers, or maybe we should do the photographers last. They're taking pictures. Okay, I've missed some people. Oh, the volunteers. All the volunteers come down here. So if you were like a dinner with strangers host or anything, just come down here. Oh. There you go. And now the photographers can come down. Did we miss any group? And I mean, you can see here that it really is Flutter and Friends. I mean, half of the people is on stage that have been making this conference together, right? All right. I think that's it for today. Thank you all for coming, and see you at the party.
Hold that thought. Let's get a group picture with everybody on
Oh yes,
stage.
everyone on stage. Come down for a group picture. And also, big thank you to the audio and the streaming people and the visual people. They've done such a great job. Big applause for them. And Friends. 1, 2, 3. Flutter and Friends. Woo! Oh, nice. See you at the party, everyone. See you at the party. Jajamän.